Okay. So we'll take the risk of starting now. I've already sent a message on Slack to the organizers that
okay, I can start.
There's something fun with this audio. Yeah, so a password walks into a bar on the bottom and says,
Is it this one?
I've seen you before.
I needed another one.
My name is Peter Hussein. Welcome to PasswordsCon track. We are starting day 2. I'm really happy to have Felipe here. Cloud attack, deserting attack, paths with graph mode.
Thank you. Okay. Can you hear me good? Wow.
Yep.
Still out. Okay, nice. So first of all, it's a pleasure to be here. Thank you for the staff team for this opportunity. And yeah, let's talk about this topic that I like a lot. And I was watching yesterday some talks here. You know, the people talk about, you know, the passwords, secrets, and something like this. And today, my idea during this morning is to share more. I will divide these presentations in 2 parts. Actually, the first part is more, let's say, bullshit part. It's the theoretic part. I know that you don't like this, but it's necessary, you know. And the second part is more, you know, the technical part, and practical is more sexy part. I know that is. Okay, let me introduce myself again. So I'm working now creating this business unit. I'm director of the threat research and advocate at Senha Segura. Senha Segura, it's kind of different name because it's a Brazilian name. And by the way, I'm Brazilian, but I live in Portugal. And I hope in the next few months to move into live here in US. But Senha Segura, it means password safe, you know, so makes sense with the with the track here. But this company is responsible for provide some identity solution and stuff like that. But my idea here is not to talk about this company, is to talk about some research, okay? And I'm very active in different communities, as you can see here. So, you know, I'm speaking Red Team Village, Adversary Village, Cloud Village, and I'm Sneak Ambassador, the open source part, of course, not the enterprise. And I'm one of the advocates of the Hack is Not a Crime. Someone or here heard about the Hack is Not a Crime? Or one person. So that's the idea behind of this project is to spread the message about the hacking. Because when you talk about, you know, the hacking is not really a bad guy or a threat actor. Because when you see them on TV, newspaper, you see something related to a bad guy. But the hacker is when you're using your creative mind, you discover something and you help some companies. You know, that's the idea behind of this concept. That's the idea. And I'm instructor, writer, and review those three magazines in Europe. So if you'd like to share some, you know, article, probably you review this. And that's me. Good picture for my mother. Okay, anyway. So that's the idea to create the Identity Threat Labs. So to discover new how the attackers are using identity to explore vulnerability, you know, to investigate how they're using tokens, secrets, how the malware works, and how they are using this secrets to explore vulnerabilities. If you think about for example, the attacks that happened for the last few years, you cannot see nothing about the 0 day. Usually it's about the third party that someone explored, or, you know, library in the code, or even misconfiguration, you know. So that's the idea, to establish this idea to understand how to create this a research center. So if you have some, you know, content about that, so I would like to talk with you, understand more how you do your research and learn with you about that, okay? So nice, let's talk about our main topic. If you are, you know, an expert, if you are a principal, sorry, but I need to put every people on the same page. So I will talk about something base, and after that we go for some terms. What is threat? Simple like this, is not my definition, according to ISO, is a potential incident that calls something in your organization or system. So we need to understand about the threats, okay? So it's a software attack, theft of intellectual property, or even identity theft. So we are talking about, you know, passwords, secrets, token, and identity, or human identity. So we need to understand those differences, okay? But when you talk about the identity theft, is a kind of threat, sabotage, and information extortion like a ransomware. It's a kind of threat. So this is one term. Very simple, probably you already heard about that. It's your first time here, so this means threat, okay? The other term is high value target. This is interesting, because probably if you have more experience in the cybersecurity field, you know how these terms works when you talk about the domain controller. Usually when you think about the high value target in this scenario, you understand that the domain controller is the high value target. But what is exactly high value target? It's coming to the military terminology when, you know, to need to define one specific person, research that enemy command is required to complete a specific mission. Okay, so when you think about the organizations, so we need to think who is the person that can be my high value target. But when you talk about the cloud, remember the title of this conversation is cloud, remember? So it's not exactly one single identity, but you have many possibilities in the cloud. So if this identity was exposed, what is the impact? So think about that. Okay. So when you talk about the high-value target in our field, we can think it maybe as a G Suite or board member or executive. But on the other hand, if you see here, it's a kind of people that has elevated privilege. So if you think about the cloud, so if you divide this room in two parts here, so we have here one group, and this another side, another group. So here we have many identities, many permissions, many rules, and maybe each person here is inside of the group permission, right? And they can be associated to another group. They have a kind of relationship. This is important to understand, okay? So that's thing. When you talk about the cloud, we have one single identity. This identity has permissions. Above this, you have a group, you have a rule, and you have many people, connected between each identity. So in this case, so when you talk about the cloud, everyone can be a high-value target. Why? Because the identity access management, the permissions in the cloud, can give the access and specifically research in the cloud. I will explain more. So this another term, attack vector, attack path. So attack vector basically is the method used for the cyber attackers or threat actors, not a hacker, okay? So that using to compromise specifically systems, okay? So it's very common to talk about malware, ransomware. Phishing is a kind of, strategy that you're using. So if you think about cyber chain, but when you talk about the human errors, you can see weak credentials. We talk about passwords and tokens and whatever. Poor encryption, MD5, SHA-1, and misconfiguration. That's the main point here in our conversation today, okay? And of course, all those things allow people to access sensitive data in the cloud. Another term is attack path. Basically, it's the graph mode. Remember, the title is the way, the visualization that attacker using in the specific environment. So this is a very interesting picture from OWASP, explained, in this case, more security risk. But you can see here, for example, the threat agent, the attack vector. You can use it, for example, misconfiguration, or even if you explore some vulnerability like in any specific application, when this thing happens is because, for example, the application is vulnerable or they have some file upload vulnerability or some, attack path, traversal path, directional path, or anything like this. You can use it for a command injection, whatever vulnerability, but you gain the access usually in the web user. You need to escalate privilege in the cloud, so when you explore some weakness, when you gain the access, you have the control of this kind of system. You can, impact a specific function. You gain the access, or you can impact the business in this organization. Okay? Now, okay, sorry, this is the bullshit part, I know, but now we talk about more sexy part. Okay? So who works with AWS here in this room? Okay, I don't need to talk more, sorry. No, sorry, I'm joking. So, but that's the point here. So if you don't work with AWS, or if you work, for example, GCP, Azure, or even OCI, or another cloud provider, the concept behind of these ideas is quite the same. Of course, when you talk about, for example, Azure, they have a subscription, it's quite different. GCP, you need to understand if you're using, for example, GCP Workspace, or Google Workspace, or something like this. But for example, OCI is quite similar to AWS. And other cloud providers is a good opportunity to make the research with me, okay? So nice, just to putting every people in the same page. So again, AWS AAM is basically the services responsible for managing the identity in the cloud, talk about the AWS specific. So they will centralize the different permissions and how you can provide the access and this research. Who is responsible for authenticating this in this case, or who is authorized to go inside of this service. Remember, when you talk about the cloud, it's different about the virtualization, okay? So I like to explain this because in the past we have a virtualization, so when you talk about the cloud, you have services connected like a puzzle. So for this puzzle works in a right way, you need to have this, we need to configure this, basically, the IAM. So the IAM will be responsible for give the access or not the access, okay? So when you enable some EC2 instance, for example, you need to attach some storage behind of this EC2 to works. It's different when you configure some VMware because of virtual machine, let's say. When you configure some, for example, virtual machine, you just set, you know, CPU, memory, and disk. But when you configure some cloud, we need to connect those resources, those services. And for those services works, you need to configure this fucking service. I don't know, I cannot using fucking, it's not polite, right? Okay, sorry. I can use here in besides. I can use? Thank you, sir. I'm relaxed now. Good. Okay, so this is the version, this is the how the AWS works when you talk about permissions, okay? How you create in specifically policy. Because it's if you work with the cloud, mainly AWS, you're a security guy, you need to configure something, we should looking from the AWS web architecture, right? Who knows this web architecture framework? Man, it's so bad. Because when I ask who works with AWS, I think 93% of this room, you know, hands up. When I ask about the AWS web architecture, I just see 3 people. So we have a problem here. Because web architecture is a kind of guidance to implement security stuffs in the cloud, focusing AWS. So if you don't know, we have a problem here. Houston, you know, that's the big problem. That's the key. Because here is how the permission works. Okay, we have a kind of statement, you know, is a kind of part of the information that you can put inside of this element. This is the statement of the permission in AWS. So for this attack happen, basically you need to look in from this effective, it means allow or deny, and the action is a bunch of list of action that this policy that you will create allow or deny, okay? Because again, this is the simple, if you see here, this is a simple EAM read-only access. This permission is default, is standard from AWS. As you can see, when you configure something in AWS, you just go to the permission and you have a possibility to using those standard, you know, policies like administrator access, EAM read-only access, you know, whatever, you know, bucket GC3, permissions, whatever. You have many different standard permissions from the AWS. But the key is here. Effect is allow. Take a look at this action. It just list and get those informations about the EAM. So, in the research, if you see here, the asterisk is safe. Yeah, that's a good point, because I should, when you enable this, usually the AWS give you some warning, because you should, you know, specify the RAN, the AWS research name, responsible for receive this permission. So that's the key. But for the security or for the management, it's more easy to put why? The asterisk. It's enough. Okay. But take a look at this. So I have a question to you. This is just read-only access. So this permission is safe or not? Why not? I cannot write nothing. Other? So, what do you think? Good. I don't understand many explanation because I cannot hear, but I agree with everyone. Probably those 3 people explain the same thing. We can read, because you can list, you know, let's say PII information, right? So you can list users, you can list groups, you can list policies. So for the attacker perspective, if they gain the access, because basically the only information the attacker needs to have in this case is one secret and one key. And after that, they can connect it to the AWS console, the CLI in this case, console command line interface. They can connect in this account, because this is the 2 main requirements. The others you can just click and enter because it's default, okay, like a region and time zone and another, don't remember. But the only information to go inside of the AWS is secret and key, remember that, okay? So after that, if you have this permission, you can list everything. It's maybe not too dangerous because you cannot write in the cloud, but for the, for the compliance or stuff like that is complicated because you can list policy, because you can do the enumeration, okay, in the cloud. That's the key. But if you see, we just can see here only 2 actions. Remember that. Okay, so let's think about this is kind of challenge that we have nowadays. Developer team access many applications, DevOps team access many systems, database team, cloud teams. This guy like to use in the cloud. I don't know why, but they like to have a permission. I don't know why, but they like. Okay, so in the past we have an admin guy, but nowadays everyone access the cloud, even the market team. No one here works with market, right? It's good, if someone works with marketing, sorry. But no, actually they need to use it sometimes because they need to create some, advertisement. It's fucking advertisement. Okay, and they request the developer to create a specifically landing page, and they request for the developer creating this. The developer do what? They create a Lambda service, okay? They run the code, and after the advertisement campaign, they delete the code, everything is safe. But now, because the user to work this, they should be, a service account user. It's continue to be there because they don't delete the user. They just delete the code because, the user, when they create an AAM, they don't need to pay for it. That's the key. Yeah, so because of that. So C-level access the cloud. So I don't want to ask if there are some C-level here because can be. I like everyone, by the way. Okay, so we have remote workers. This is nowadays it's quite hybrid, but some companies continue to be remote workers, and inside the fucking threads, okay, they gain the access inside of the environment. And that's an interesting point when you talk about insider thread, because sometimes some people imagine that the insider is the guy that works in the darkness, But no, it's someone that's enable a specifically misconfiguration. Pay attention on that. Oh, yes, the marketing guy, that's it. It's the movie guy, exactly. No one marketing here, right? Just C-level, I know. Okay, so that's the key, is the marketing guy, so the move. But nowadays, they're using they don't disable all policies. They just set some misconfiguration, Oh, it's a kind of error here. That's the insider thread works. And what is the impact if someone is attacked? Just think about that. Okay, let's talk about the other sex part. So, to do this attack, actually, we need to, again, have the access key and the secret, or the key and secret to connect. Remember when I mentioned it? So, let's suppose that I gain the access, and this is specifically AWS console. So I try to use in this list user, as I asked you before, remember? So just this guy don't have, for example, read-only access because the access denied. So good point for, for the security team. I try to list some policy and access deny. And I try list groups, deny. Okay, the security team works good here in this case for the specifically secret and token that I had. So let's suppose now, if I have new, or I would like to show you the impact about one single action. So I will create a specifically policy, and take a look at this. I just put into specifically policy here, and now policy, 2 actions. If you see here, one is inside of this permission management. So AWS basically has 3 groups. One is write, another read, and another is permission management. And inside of each group, we have a bunch of actions. So when you enable some standard permissions in the cloud, remember standard policy in the AWS, there are a bunch of actions inside of this policy. So because of that, it's important to look inside of each action. Why, Philippe? Because I will explain now what is the impact, okay? So I put in asterisk here, take a look at the color, This color is quite, I don't know, orange, yellow, I don't know, whatever, but it's a warning, okay? Okay, take a look at this. I call attack module, and I using the custom managed. It means I create my own policy, okay? And if you see here, actually I just enable one single action, create policy version, you see? Then research, I create for all policy here, the asterisk. This is a kind of, remember the statement that I mentioned? So what is the effect allow in the action create policy version? So let's see the impact. By the way, I wrote an article and I'm publishing in Pentest Magazine. I think this article's in my LinkedIn as well. So I explain these attacks in details, but to gain this information, I just type in the Google how I can create the full access in AWS using CLI. And they suggest me this code. If I am, newbie, so I just copy and paste this code. If you see here, the actions is AIM, so asterisk, so I can access everything. And let's suppose that I don't have any knowledge about the cloud, so they suggest me some organization stuff here. So if you don't know, organization is the main account, not main account, but when sometimes the company has an organization, and behind of this organization, they can have more than 50, 100 accounts. If the company is too large, usually they use a different account in, behind of this specific organization. So remember, I just type in on Google and ask how I can have the full access in AWS. And they suggest me here. But on the other hand, if I don't know how I can type in CLI, you can ask it to Google how I can create a policy version. And they suggest you the AWS code, well, actually the AWS command. So in the article, I put how I discovered this information. Basically, if you see AWS AAM, the service, create policy version, because I will create a new policy. I need to set here the REN, the POC attack module, and I can set the policy document, as you can see here. And this is the document, attacker exploitation. Remember the file that I created here? This is the document here, attack exploitation. And I set here, and if you see here, I put in set as a default. What happened in this case? I had this permission, only one single action. But after that, I can escalate privilege, and I can have not only the one account, remember? So I have one single account. So now I have an access to organization level. I like the expression. Oh, man. Yeah, that's it. The point here is the misconfiguration in this case. But it's not it's misconfiguration, but the security guy should looking for each action inside of the AAM server. But it's too much, Philippe. I know. In AWS, you have more than 6,000 permissions. It's a good challenge, but that's the key. So here, the attacker can escalate privilege just because you set, in the end, set as a default. So after that, you can list, you can do many things. Just a simple example how it works. Okay, how I can see, how I can, not only investigate this, but how I can mitigate this. Or if I work with a offensive side, for example, how I can explore this. So this is one of the tools that I would like to share with you. Is an open source tool called cartography. Basically, if you see here, this is the graph. Okay, they use a Neo4j. It's very known when you talk about the graphs. The graphs mode. You have here, for example, this in blue color. We have a policy. You have here the principal, and or even a statement in this case. And here you can see the AWS groups, and here you can see the users. So basically, this cipher query, you can match the AWS principal. It's a kind of high-value target that the tool use. They will set or call actually the policy. They will, search for inside of the policy statement. Remember the statement, and they will try to find where create policy. Create policy is another action. Create policy version is one action, and create policy version is another action. But if you set the flag set as a default, you can, again, do the same attack. That's the key, because you set as a default. The only point here to not give the success in this case, and if you have more than 5 policies in this custom policy, because AWS just allow 5 default policies, okay? So that's the key. And after that, we will return this information in the graph mode. In other hands, we have another tool called AWS PX. And I like this picture because you can see how complex it is to work with cloud. Because if you see here how many actions you have here. I have here, by the way, I think, here I have AWS PX. So we can set from any place, for example, you can set here the effective admin. It's a kind of high value target they use here. It's very similar when you think about who knows Bloodhound here in this room. Okay, it's very similar, the graph mode, how you can use and how you can set, how you can see some attacks, basically. So if you see here, so we have some users. Those users here work with cybersecurity, let's suppose, I think. No, not suppose, because this guy here, our C-level in this room. And they have administrator access. This is the standard policy, you know, from AWS, by the way. I don't do nothing here in this case. It's just administrator access, standard from AWS. And here I create another permission, Thor Lab, and I create another group level here, the user default that we have here, Ted, James, and Bill, just names, okay? And if you see here, this is the path, and take a look at this one here. I would like to see, for example, like a Thor here, the name Thor. So in all the actions, so you can see here, where's the Thor here? It's, no, not Thor, I like this one, Anna. Oh, Jesus. Where are you, Anna? By the way, Anna is the name of my wife. She will kill me because I'm using her name. Oh, yeah, on top. Yeah, take a look at this one here. So let's see these actions. Let's see the impact that she has, my wife. Definitely she will kill me. Okay, take a look at this lady. So we have here create login. Oh, we have a change password here. Why she needs to have this action? But Philippe is default for it for administrator access. That's the key, you know. This is the impact. So we have this one. And this is the explanation using the tool, you know. Grants permission for AM user to change their own password. So imagine if this AWS key or secret was exposed, the attacker can change the password, and the user is gone, basically. Okay. Nice. So how we can help in the community? How Senha Segura, my company, again, can help the community? Here, I would like to share with you some community product, okay, that you can see in the graph modes. It's the same case, okay? And how you can use in this. This is totally free charge. It's community version. I will do a demo here if the lords of demo help me. But I will try with this internet connection problem. Let's see what happened, but I will try. But I have here the demo as well recorded, okay? Basically, let me go to the demo. So you can access here, after you do the registration in this web page, you have here the access. The cloud entitlements is a community here. It's just free. You can integrate with 3 different cloud providers. Again, when you connect here, you can see some recommendations about the identities, how you can manage it, for example, how you can change in the administrator access, how you can change the MFA, some recommendation based on those actions, okay? So we talk about the graphs. So I developed in this tool the attack path mode here. So I just show the example. So here this user can have this attack path based on the attach policy. This is another action. So if you have this action enabled for each or whatever user that you have in your organization, this user, it's possible to attach another policy. So if they have some, no high access, no sensitive, permissions in the cloud, but if they have some attached policy, they can attach another policy or rule. Here is basically, if you see here, the description of how we can use it. This is the requirements that you need to have, and this is the impact. Privilege escalation, credential compromised, and operational interference. Basically, you can see here. And you can use in this, again, it's totally free, community, and we are developing this tool, and not only this, but basically the people are using. If you see here, sandbox mode, you see here in the orange color, So you don't need to integrate anything, okay? You just, when you receive the access, you have many data populate there. It's a fake data, of course. But if you'd like to use in your lab, in your environment, whatever you want, you just disable that flag here, and you can integrate your environment, like this one here. I have my own lab. Let's see my lady, my wife, in this case, internet problem. And you can see here, you can do the integration. But just, again, the idea here is to spread the message about the identity security and how you can using this product. It's totally community. And one of the things that we created this for the improvement for the future is to work with AI, Gen AI here. In this case, if you see, so we should enable for many users to change these actions about MFA. So we have here the security intelligence. You just click here, and they use suggesting the code. As you can see, you can using. So how I can change this action in my environment? Just that you generate in CloudFormation or Terraform, for example. And after that, you just copy this content, create the file, and that's it, okay? It's not enabled now, but the feature of this project is to have this apply remediation. It's a kind of automation process, okay? So we have here 7 fix, and if you apply remediation, they will start to connect to in the cloud and works, and they will remediation this environment, okay? So you can see for the attacker perspective, if you work with offensive security, you can using. You know how many users you have in your environment with these policies. You can see how you can explore those guys. And if you work with defensive side, you can see this big picture. You can watch in this. Again, it's free, and how you can help in the community, because we receive a lot of things from the community, basically, okay? I record it if I have some problem, but it's not necessary. And I finish here the presentation. I think 10 minutes before. So I don't know if someone have a questions. No difficult questions. No difficult questions, sir. Go ahead. So there are one question. No difficult questions, sir. Please. You know it's difficult. The mic doesn't work. Let me talk with everyone here. Yeah, 1 second. Yeah, the question is about the attack path is related to the AAM, how it is connected about that, right? Yes. The attack path basically is how the attacker can see who is vulnerable to attack the environment. So for example, if you gain the access in the environment, we have two visions here. We have, for example, the defensive side and the offensive side. So the attack path is totally related to the actions. Because to give you this in graph mode, I need to have the identities. I need to have the user. But for each user, when I do the rediscovery, we need to see how many each user has each action. For example, the attach policy, they need to have 3 actions mainly. Okay, the attach rule, attach group, and attach user. So we have, in this moment, this project has, for example, 4 attack module. But I will create more attack module. For example, so there are specifically actions for the bucket S3, for example, like a put the object inside of the bucket S3. So I can create an attack specifically focus on bucket S3, another service, that the user needs to have, for example, a bunch of actions, but specifically this action, put object in bucket S3. So when I do the discovery, when we find, for example, 10 users, I see these 10 users can suffer in this attack path, because this attack module actually. So the graph mode is just to facilitate the vision, but the characteristic here is how the action is connected to the identities, I answered, yeah? I think we have one more question here, or there.
Thank you. So I love this talk, and I love how you talked about AWS, GCP, Azure. I think those other two cloud platforms don't get a lot of love when we talk about cloud security. To that point, and this is a little bit of moving the goalpost, but I kind of wanted to hear your thoughts on this. There are even more cloud environments that we kind of have to worry about when it comes to permissions. I'll give you an example, Cloudflare.
Mm-hmm.
I consider that a cloud environment, and that's something I actively worry about access. One, I would ask, what are the tools that you would point me to start doing this kind of analysis in those kinds of environments? And two, how would you kind of, hypothetically, even if there isn't a tool, where would you start?
Good question. I thank you for asking. Actually, when you talk about, you mentioned more than cloud providers. You mentioned other platforms. And I have one of my challenge here in this Identity Threat Labs is to understand how the attacker are using, for example, GitHub Actions, or GitHub or GitLab. So you can see, think with me, imagine for the defensive perspective. So if I can just run a discovery in my environment, and I can see the whole path comes to GitHub, and after that they go the access based on CI/CD, the GitHub Actions. Based on this integration, they are inside of the Kubernetes. These Kubernetes are inside of the AWS. Because of the permission in the AWS, you can map the whole things. That's the idea for the future of this specifically project that I'm working. There are another open source project called Starbase from Juniper, if I remember correctly. This specific project, this project is not focused on security, but they are a data resource actually. So you can integrate with many providers, like not only cloud, but for example, sometimes as a kind of security solution, like Tremicro or CrowdStrike. CrowdStrike is not so good. Mention it. Okay. Anyway, that's the point. So when you have the big picture, that's the good delivery for the companies. That's the idea. I have some research. I did some research focused on Okta, because it's identity provider, so how they connect with the AWS and other service. In my previous company, I created another attack module when do you integrate, for example, the Active Directory with Azure, not Azure ID, but Entra ID. I don't know if Microsoft changed the name again. But anyway, when you integrate this Active Directory with Entra ID, so you need to install the agent. This agent will be responsible for integrating the Entra ID. And the point is, this user need to have the domain controller permissions from the Active Directory, and they create a Microsoft Online services inside of the domain controller. And this account will be responsible for connect with Entra ID. So this services is Entra ID is the high level permissions. I don't remember the name of the high level permission now, but not the owner, but whatever, it's the high permission. So if you gain the access inside of Entra ID here, you can escalate privilege from the Entra ID. Just if you discover the Microsoft Online account, because they use, when you install, usually the administrator didn't change. He doesn't change the standard name of the integration. They use a Microsoft Online fucking name or whatever. They don't change it, because it's the standard, And if you go inside of the Active Directory and you discover how many Microsoft Online you have, you can see how many accounts in this specific domain controller you have connected with Entra ID. So you can escalate privilege. Of course, you need to escalate privilege. You need to block this user. It's not too simple to gain the access, but you can see the way, like DC Sync or whatever other attack. But that's a super nice. We have many things to research when you talk this topic.
Thank you. More questions?
I think no, because
A bit of feedback. No more questions. Okay, thank you, Felipe.
Thank you, guys. Appreciate. Have a nice day for everyone.
And we will be back with more ABS talk.
All right. So I asked ChatGPT, why did the attackers target Duell? They wanted to brew up some trouble and leave everyone hopping mad. With that, thank you BsidesLV for the opportunity to present today. I'll share approaches for implementing authentication for internal applications, specifically targeting small and medium enterprises using AWS and Zero Trust principles. The slide deck is on the QR code, so please feel free to scan it, download it. I'll give you 5 seconds. All right. Here's our agenda for the talk today. I also want to disclaim that any of this work is not affiliated with my current or previous employers. It's the result of my work that I've done since beginning of this year with smaller companies as a consultant and advisor. With over 16 years of experience in security industry, I've had privilege to work with large enterprises like PayPal and Robinhood. However, my recent focus on solving security challenges for small and medium businesses has sparked this new passion of researching scalable, cost-effective, and time-efficient solutions. While we did not know what happened with all the breaches that we saw in the first slide, I didn't go into every detail of the breach because I don't know all the details. I hope you draw some commonalities. The data that was breached is obviously I can bet on it. It was not publicly available. It was not expected to be publicly available. It meant that attackers could probably have hijacked the private networks or slash VPNs in some cases. Or they may have a malware on the device from where the users were trying to access the data. Or there are a lot of different ways of attacking the scenarios. One clear thing is that the protections provided by traditional VPNs are no longer sufficient due to the use of cloud. On top of that, we have vulnerabilities in the VPN software itself that are worth noting. So what's zero trust? Do we have a solve here? Let's see. Zero trust is a framework for performing continuous authentication and authorization of actors based on different signals. As you see in this diagram, you have device signals from what's the device and what's the posture of the device. You have network signals, geography, region, IPs. You have actor authentication, which is either password-based auth, MFA enabled or not. You have permission signals of the authenticated user, what permissions they have to access the resource or not. And depending on all of that, there's this central thing allowed to access. Enforcement point says whether I can access the resource or not, and that it happens on a continuous basis. That's the framework's guideline. And depending on the criticality of the resource, the policy can be tuned and configured. It sounds great from security perspective that we are doing this continuous auth N and auth Z, but implementing it could require a lot of work for the company. And specifically, we're talking about small and medium businesses here. The question is, how do they prioritize security over business goal of survival? I had an opportunity early this year to work with a smaller company that had team members in US and India. The staff members were encouraged to buy their own laptops, use it for work. The company also employed consultants. They can work from their personal laptops, no restrictions whatsoever. As a malicious actor, my motivations to compromise a smaller company could be that I want to attack, abuse their infrastructure, and use it for my own gain. That is, pay my bills on the company's dime. Let the company pay my bills, lock their intellectual property, and hold it for ransom. Get hands on the sensitive data that the company has, and use it for my financial gains. If an attacker locks down a database of a company, and the company is large enough, they can always negotiate or pay the ransom. So a smaller company like mine that I interacted with, it could be catastrophic. It could simply just shatter their business. In this particular case, our company's infrastructure is all in AWS, which is a good thing. I'll tell you why. I'm simplifying the setup here. There's a dev account, dev AWS account, and then there's a production AWS account. We have a VPC that has public subnet and private subnets. The public subnet hosts a web server, which hosts a web application. Private subnet has application servers, databases, and things of that nature. But when we talk about a malicious actor, I have multiple entry points into the company. The multiple entry points are, it could be application vulnerabilities on the VPN servers or the app servers, or on the left side of this, you have long-lived credentials, SSH keys, username and passwords for internal apps, VPN configs that don't really change, the private keys don't really change, and that's a lot. I as an attacker, can abuse that and use it for my advantage. In the next slide, I'll talk about approaches, how to minimize the need of these static credentials and use zero trust principles. I'd like to touch upon a capability from AWS called AWS Systems Manager. I'm hoping some of you have already heard about it. This capability, when clubbed with components like IAM Identity Center, permission sets, IAM policies, session manager, can actually provide ephemeral access to the infrastructure to private resources without the need of a VPN. The sample policy on the right that we see here, it just says that an actor who's assigned this policy can access resources tagged as development using ephemeral access. What that means to our diagram here from an attacker perspective. Now the red box is turned into yellow, which means that there's only limited window of time where these credentials are valid, when an attacker can actually use it, but only use it for limited time. We certainly have vulnerabilities or possibilities on the public subnet of production hosts, but that's going to be the case. Let's jump into a demo into how that actually looks in action. All right. As I go into the IAM Identity Center, okay, hopefully this works. Okay. And I authenticate using my IDP credentials and MFA. I land into the AWS console. And from there, I can get temporary credentials to log on to AWS. And these temporary credentials, I use an environment variable to just do my job. I have wrapper scripts here, which are basically SSHing to instance using SSM. And as a developer, I'm just going in SSH and do my job, what I need to do on the host itself. The second example that's going to come here next is how to access the internal web server itself. That's a port forwarding capability of SSM that allows us to forward a port, local port on the local host, to a remote port. And that's how you can just simply access the web server through port forwarding. So it's just going to come here, access the web server using localhost, Nginx server up. But when I terminate the connection, the terminal is down, I can no longer access the web server. Third example is accessing the RDS database or MySQL database using SSM. I have a private database, I want to access it, do my job, run some commands. How do I do it? And that uses the remote port forwarding capability of SSM that was released in, I believe, 2022. I just connect to the tunnel, and that using the tunnel, I open a tunnel terminal, use MySQL command line utility, and then boom, I can actually access the database directly. What do I have to do? So once session is terminated, I can no longer access the database. All right. So we saw what SSM can do, but there are needs in an application or in an enterprise where these web applications using port forwarding is considered a friction. And accessing across multiple applications users may be tricky. That's where AWS Verified Access comes in handy. AWS Verified Access is a zero trust implementation by AWS to access internal web apps without a VPN. The components here are listed here. Let's just talk about how do they overlay with the previous architecture, with the previous framework that we talked about. The user trust providers listed here are the ones that are going to be enforcing authentication, strong authentication and authorization. The device trust providers give us device signals. And then we have verified network signals and permission assigned to the individuals are grouped here as verified access groups, and they can be configured using CEDAR policy. CEDAR is the policy definition language by AWS. Verified access point is the actual public endpoint through which the resource is exposed. And verified access instances are just an aggregation of all these different components together. Let's jump right into a demo. The beauty of AWS Verified Access is that you would access the resource as if you're accessing the resource directly on the internet. Here, I am accessing the resource. I'm redirected automatically to the IAM Identity Center. The web application that you saw didn't have any authentication. I authenticate using my MFA. And once authenticated, the AWS Verified Access runs a policy check to allow access to the app or not. How does that work in function? How is it configured behind the scenes? So we saw here that the domain application nginx.sbd.today is actually mapped to an EC2 instance on port 80, which is an insecure port. As security professional, we would not want anything to be running on port 80. But in our cases, it's possible because it's all in the private subnet. And it's all behind a security group that allows port 80 to be exposed only to this particular service here. And then we have verified access group that is allowing a policy saying that anybody who has email address like sbd.today can access the resource once they are authenticated. You can have much more complex policies based on principal, actor, and resource. Here the policy is being referenced as, this is the trust provider that we talked about, a user trust provider. It's been referenced by a name called devlog instance. Okay, before I come there, while all that sounds fantastic, there are some practical considerations we need to be aware of. One of the things that specifically with verified access is a relatively costly service. And why is it costly? What the cost implications are? It's actually AWS charges it by every endpoint or every app exposed per app hour. There are charges of amount of data that is being transferred back and forth using the endpoint. Take a look at the monthly and yearly costs of if you have 1, 10, and 50 applications exposed using verified access. It's worth noting that it's not a pay-as-you-use model from a user interaction standpoint, but pay-as-active cost model. The following 2 slides discuss on different approaches on how we can minimize the cost while keeping security in balance. One particular approach that I can think about and we used is we can put similar trust level applications behind an application load balancer, and then ALB is the one that is front-ended by verified access endpoint. This is good from a cost optimization point of view, but it also limits our policy rules, that the policy rules cannot be differentiated based on app 1 or app 2 resource access. The policy will only know the ALB endpoint. Other approach is to terminate the verified access endpoint when not in use. This can be achieved by implementing bring up and bring down kind of architectures using automation. In this example, we just talk about the endpoint, verified access endpoint coming up at the beginning of the day. And when the work is done, when we are sleeping, when the workforce is sleeping, just destroy this infrastructure. It takes around 10 to 15 minutes. So if your threshold of bringing up and bringing down is okay with 10 minutes, then you can implement this strategy and reduce the cost by potentially around 50%. This concludes my presentation. Let's hear a quick recap. In my opinion, zero trust principles are must-have for even smaller companies. AWS SSM is a good capability to explore and keep in mind without incurring any cost if you have a smaller team and limited resources. Verified access is a great mechanism. However, the cost is the limiting factor for smaller companies. AWS at someday I hope that will minimize that cost and we can make it much more useful. If you can remember just one thing and only one thing from this presentation, I urge you to take this. Implementing good security controls is not about money and time. It's about intent. However, we also need to make sure our industry keeps that in mind and makes security controls accessible to companies of all sizes. Thank you so much for listening to my presentation. Here are the code references for the code demo that was presented earlier. You're also welcome to join the Slack community if you want to discuss about how to help smaller companies in making them more secure. That's all I had. Open to questions if we can have some time.
Questions? Raise your hand.
Go ahead.
Hi, thanks. I didn't understand how the access changed once you had like the verified, like because you were like SSHing into the database or into the on the virtual network, and then you showed that then you had the verified access, and then you logged in like through the UI, and the policy was applied, and then how did you get access to? How could you run your database commands?
Yeah.
I didn't understand that how that worked.
Yeah, that's a great question. Verified access actually works with only HTTP and HTTPS endpoints and not with your database access. So when you want to access the databases, SSM is the best bet to go forward with, and SSH into the containers. SSM is the right solution to go forward. Verified access will not help. Verified access is to solve for situations where you have a dev web server, dev application running, and you want to test it out, or you have a Jenkins instance that is hosted in the internal network that you want to test it out, without really adding a lot of authentication capabilities on the app itself.
Any more questions? I have honestly, I need to be honest with you, I've never worked with AWS, so I can't really think of any questions for you on this one. So thank you again, Rohit, for being here and doing your talk.
Thank you.
And we'll start again at 12 with Norwegian. complex password or a long, simple password? I do recommend using simple passphrases. When I talk to my mom, my sisters, as an example, or my girlfriend that are absolutely not interested at all in what I do, I say use a simple, positive passphrase, a sentence that is easy for you to remember. That could be something like you learn as a child, but it's specific to you and it's a positive memory, something you actually want to remember. So sort of like stay away anything that has to do with your wedding date might be difficult in the future, as an example. But that's what I'm using as the master password for my password manager, which is one password in my case, and then I will let one password manage the rest of my passwords. And not only that, but I have written down my master password on a piece of paper that's in some envelope saying for emergency purposes only, and I have that envelope somewhere at home. My ex-wife, my girlfriend, and my daughter knows about the envelope, and they know that if I don't come home from the US, as an example, what could possibly go wrong being here, then they will open that envelope so they can get access to my accounts and delete that when I'm gone. That's a very simple recommendation for you. So with that, I'm really happy to introduce my friend, something BD, Åse from Norway. That's not my name. Thank you.
Is this thing on? Yeah. So, first, a little backstory about this talk. After receiving yet another marketing email butchering my name during Christmas, I posted this text on Facebook, inspired by a song by the Ting Tings. Let's see if I don't know if I have a network, so. Yeah, that's enough. My name is Bård. I also go by Bard, Brad, Board, and so on. Online, my identity is Elzap. I'm a platform engineer at DNB, the largest bank in Norway. I am an avid supporter of the free and open source software movement, and and have been organizing meetings for Bergen Linux User Group for more than 10 years. I have 3 kids and a wonderful geeky wife. And I am a geek. To me, that means that I like to go deep into things and figure out how they work. Are you ready to do that together with me today? Geeks sometimes measure their geek power by showing off their understanding on how systems work, kind of like I'm going to do with you today. One common way to do this is to show that you can write something in binary. I have not memorized how to encode my name in ASCII. Mostly because it cannot be done. ASCII does not have O. As a kid, I did actually try to find out how to my name was encoded in binary. This exposed me to the weird world of character encoding. There's not one way to encode characters. There's an infinite number of ways to encode characters. Some make sense, some maybe not so much. Most modern character encodings use ASCII as a base and builds onto it, which is why the problems usually occur when you go outside the US ASCII space. When talking about encoding, we don't usually use the binary codes. We usually use the hex codes, which is easily converted to and from binary and is easier to relate to and takes up less space. But for the explanation's sake, both kind of matters in this talk. Now let's go into it. What is character encoding? Simply put, character encodings are mappings between numbers and characters. We, as humans, like to work with text, graphics, and sound, while for the computer, this is all sequences of numbers. But we encoded text long before we had computers, though. Think of Morse language as a text encoding. It's even in binary. ASCII also predates computers. Even numbers needs to be represented as character code points. Back in the days, operating system vendors came up with their own encodings for various regions. And this was mostly okay, because computers rarely process documents from other regions or even from other operating systems. Microsoft dominated the market, and if you're using a different operating system, it was mostly up to you, onto you to find the right encoding so you could communicate with others. Furthermore, no one really expected it to be easy. Then the World Wide Web came around, and we all started connecting to the internet. It suddenly became very common to communicate over large distances. Unless instructed otherwise, browsers still expected all documents you encountered to have the same encoding as you were using locally. Even though Unicode was invented roughly at the same time as the World Wide Web, and UTF-8 came around in 1993, we started using HTML entities to make sure that text was correctly displayed. In 2003, we are still using HTML entities, 10 years after UTF-8, to make sure that the Scandinavian characters were correctly represented. HTML entities is yet another layer of encoding on top of ASCII. Imagine how many times I've received emails greeting me like this. It is disappointing when my name cannot be shown correctly. I mostly find it entertaining, but there is no doubt that other people are more seriously affected. Names are no laughing matter. Today, Unicode has won, and we have an agreed upon way of referencing every character under the sun, and then some. You would think encoding issues were something of the past. Unicode has its own set of problems, but we still struggle with the sins of our past. UTF-8 were supposed to fix everything, and to a large degree it did. But we have a huge amount of data already encoded with the old encodings, and a huge amount of computer systems expecting and producing the old encodings. We started a transition that we might never complete. IANA, the Internet Assigned Numbers Authority, currently recognizes 259 standardized character sets. To this day, Azure DevOps, the Azure DevOps front page greets me like this. A couple of weeks ago, I had a kebab at my favorite kebab place. Notice how they omitted the umlaut over the Ö in döner, and how vår referanse, it's Norwegian, is displayed. I have not been able to find out how this, how or became these symbols yet. But I bet it started with a wrong assumption about the input encoding. I have lost count of the number of receipts, emails I get greeting me with B, A with a tilde, yen sign, RD. This is by far the most common misdecoding in Norway, based on my empirical observations. It's of course the similar errors with and a. This happens as a result of interpreting UTF-8 as if it was ISO 8859-1 or ISO Latin 1 or Windows code page 1252. At S-Banken, we used a deployment tool called Octopus. They keep sending me emails like this. Any guesses what happened here? This is most likely the result of assuming your UTF encoded input is Macintosh encoded, also called Mac Roman. Macintosh Cyrillic would also produce the same result. And this is the email I got from B-Sides. I'm not sure if this was a joke, because the first few emails were correct, and then the last email was like this. Weaveworks addressed me like this in emails. I'm not sure how it happened here, or even how to pronounce this. If you know, I would like to know, so please tell me. Perhaps it's the same error as with the kebab receipt. And then there's this. A local company in Bergen used to send me emails where they wrote my name like this. Is this kind of threat or something? This symbol is called a dagger. I looked into this and concluded that they must have stored my name somewhere using code page 850, also called DOS Latin 1. And then, and then they have interpreted that as if it was Windows code page 1252, which is usually referred to being the same as ISO 8859-1, but in the range from 80 to 9F, ISO 8859-1 is undefined. This is to allow for control characters and other adaptations. This is where we in Windows code page 1252 find the dagger symbol in the same position. The Web Hypertext Application Technology Working Group decided in the HTML5 standard that whenever you specify ISO 8859-1 as encoding on a web page, code page 1252 should be used instead. Although this technically makes sense, it adds more confusion. You get access to way more symbols with code page 1252, and Windows users probably already expected all those characters to be there. At AWS reInvent, I talked to some sales representative for Kong and let them scan my badge. They sent me this email. And now we're going to see how that happened. I have a fairly good idea of what's going on here. Most likely, it started like with Octopus, interpreting my name given to them in glorious UTF-8 as if it was Mac Roman or Mac Cyrillic, and encoded the result as UTF-8. Then they have read that encoded UTF-8 encoded string as if it was Windows code page 1252. Or less likely Windows code page 1254. Many computer systems are configured to take the local vendor specific encoding as input and storing the data as UTF-8. And if they then read the data again and stores it again, they will encode it once more. For every system your text passes through, there is a new opportunity to make an encoding error. In the previous example, it has been misinterpreted at least twice. It could have been misinterpreted more times, but accidentally or purposefully repaired. Even text that is correctly represented may have been encoded wrong somewhere along the line. Because sometimes we developers fix problems in one system that was caused by another system. Can you imagine what happens when the original system then gets fixed? Yes, yet another misencoding. Here's another example of interpreting an encoding wrong twice. It's amazing that this shipment actually arrived. So let's see. This is the result of first interpreting UTF-8 as ISO 8855-1 or 15 or Windows Code page 1252, encoding the result as UTF-8, then reading it again as Windows Code page 1252. Another interesting thing you can see from these examples is how one character becomes two. This is because while ISO 885-1 and other traditional encodings uses 1 byte for every character in its character table, UTF-8 makes use of a dynamic number of bytes to represent each character, giving them more than enough room for all the known alphabets in the world, living or dead. This is how they found room for the beloved pile of feces emoji and all the other emojis. New emojis are introduced all the time. In UTF-8, the Scandinavian characters are represented with 2 bytes. Or are they? Take the letter O. O is the 197th character in the Unicode character table. In UTF-8, this becomes C385. This is 2 bytes. But it could also have been encoded as a composition of capital letter A and combining ring above. A is 1 byte for 1, and combining ring above is 2 bytes, CC8A. Together, they make 3 bytes. It's also optional in which order these byte comes. So it could also be not only 41 CC8A, but also CC8A 41. To make matters even worse, Unicode also defines an additional character that looks exactly like the Norwegian character O. If you encounter this, it's most likely you're most likely a physicist, or you're dealing with text that comes from some kind of optical character recognition system, or you're just a geek. Or the Angstrom sign is a unit of length named after the Swedish physicist Anders Jonas Ångström, with an O, not an Angstrom, and is encoded as E284AB, 1 angstrom is 0.1 nanometers, in case you wondered. Encountering this character is apparently so rare that many applications will convert an angstrom to an O behind the scenes. This is also in line with the current recommendations from the Unicode Foundation. In fact, this also usually happens if you try to use the combining ring above, but not always. Plain text is not simple, it's just unstructured. There's nothing in a plain text file telling you what encoding it is in. You barely have an optional file extension that tells you that it is plain text. If you receive text from an input field or the clipboard, you don't even have that. Image formats and other formats we deal with usually have a header that tells you what format it is. But with text, we often just have the encoded text itself. In UTF-16, there was an attempt to creating such a header. UTF-16 had 2 different modes, little endian and big endian. This controls the order of multi-byte characters. If the first 2 bytes are FEFF, the text encoding was little endian, and if it was FFFE, it's big endian. This is called the UTF-16 byte order mark, or BOM for short. This required all software dealing with text to inject the BOM when you cut and remove it when you paste. With lots of legacy software, it didn't work so well. You might have countered the BOM if you opened a plain text file in Notepad and the first character is a black square, while the rest of the file looks fine. However, it might also just be a Y with a hat in ISO 8859-14. I have compiled a list of resources it's a GitHub gist. So if you scan the QR code, you can find that. Otherwise, I'm done with the talk, and if you have questions. Yes? Or microphone.
Great talk. Do you think in 20 years from now, Elon Musk's son will be having the same problem as you do? Because he also has a Norwegian letter in its name.
It's probably already happening.
I also told Bård here before he started his talk that you need to ask the audience, have anybody else in the audience, should I say non-English characters in the name that are causing problems? Yeah, so more questions for Bård.
Have you encountered problems with passwords where you use those characters?
Not me, but Per told me about a situation where.
Yeah, I can do that one. The Ukraine.
It's no, not that one.
Oh, okay. Yeah.
But where it's about these combining characters, where on iOS devices they are combined to one character, while on PCs they are separate symbols. And someone created a password for their bank ID in Norway. I have not confirmed that this is the case, but it's most likely the case, since she were able to log on to her bank ID from her phone, but not from any other device.
Yeah. I remember way back in 2007 was my first time visiting Kiev in Ukraine, the capital, visiting colleagues there back then. And out of curiosity, of course, I asked them, have you ever considered doing passwords in using Cyrillic characters? And they just laughed at me and like, you have no idea of what kind of world of pain you're going to be in if you do that. First of all, if we travel to the West, you don't have, a keyboard layout with Cyrillic characters on it. But the second one is like, and I'm sorry for saying this, but most of you people in the West, you have no idea there exists more letters in the world than A to Z anyway. So they were just like, that is the most stupid thing you can do. And I've talked to people from all over the world and still ask this question: have you ever tried to do this in Greek, in Arabic, in Chinese, in Japanese? And usually the answer is no, I wouldn't dare try doing that at all, because it's just going to make a lot of problems for me.
Perhaps a more security-related question, but did you ever encounter any potential attack scenarios? I can imagine if your name gets converted to something with an ampersand, that could be seen as an extra parameter somewhere, or for example, maybe a normalization attack in an email address that could, I don't know, lead to another user being updated, stuff like that, maybe accidentally. Did you ever see any of that as a life experience guy?
Well, this example with this, imagine this being appended to a URL. So yeah, that can happen. And there is also these cases where, oh wow, there's a lot of echo, where you have, there's more symbols that look the same in Unicode, like the Ljungström sign and the O. So you can register a domain using a different character set, and in that way make it look like it's the same domain as your bank, for instance. So A is famous because you have a symbol, a Cyrillic symbol that looks exactly the same. Or in many fonts it's actually quite a little bit different, but it's similar enough that people don't react to it.
Yeah. More questions? Yep. In the back. And we are already into lunchtime, so those who want lunch leave, and those who want to discuss this more stay.
Tusen takk for the presentation, veldig bra. Bard, sorry, calling Bard. Bar. Wondering about this. Why do you think even Norwegian companies, Norwegian bank statements, Norwegian salgskvitering was showing your name? Why do you believe this is still happening inside Norway? Not really only related to international communication where character conversion could be explainable, but why are we still facing that? Thank you.
So as I touched on to, there is nothing indicating what encoding a text is in. So this is all of this is with text, with character sets that already accept the Norwegian character, and but you just don't know which encoding it is when it comes over the wire, and most of these issues is exactly when a system tries to fix the encoding. They get something in as UTF-8, and they assume it's the old encoding, and they try to fix it by making it UTF-8, and then you get another misencoding.
More questions for Bob?
Not a question, but I noticed the characters on your header on the slide changed from side to side. Nice touch.
Yeah.
Okay. Then no more questions for Borg. We'll cut off for lunch. Thank you both for coming and doing your talk. And we will get started again at 2 o'clock with Ron Nissit.
something spooky to phone in. I'm just trying to give you something. I'm just trying to give you something spooky to phone in. I'm just trying to give you something.
just-in-time access. So please welcome him with a little round of applause.
Thank you a lot for having me. As stated, I am not a professional at doing the stocks, but I will do my best. So short introduction, nice meeting you all. I'm Avi and I'm the co-founder and CTO of Entitle. At Entitle, we're doing just-in-time access for cloud resources. And yeah, recently we got acquired by Beyond Trust, so my boss is sitting over here. So before we kill something, let's maybe first define what is PAM. And frankly, to be acquired by a PAM product, as we saw at that time, PAM products are doing the provisioning, deprovisioning, and session audit for privileged permissions. In the old times, those sensitive permissions were for all systems, some database that were on-prem, and as we will see throughout this talk, things have changed in the cloud. So, according to a lot of marketing stuff, a lot of people have a lot of permissions, and most of them are not used at all. Like we will see shortly that most of the common breaches nowadays are revolving identities and over permissive permissions. And even though we have so many admin accounts in the world, most of them are not used at all, not throughout time, but even in general. People, and by people I say DevOps personnel in IT, rather give over permissive permissions instead of fine-tuning that because they're just flooded with tickets. Yeah, so many of the recent breaches are identity related. One example will be the Okta breach. In the Okta breach, we can state that a support engineer had basically admin rights to all environments of many customers, and he had a lot of other problems. As you can see, he didn't have MFA, et cetera, but with one identity, we were able to compromise the whole company within minutes. And this is screenshots of Luspus group that they showed how they compromised many companies. So now that we know what is the problem, what we can do about it. When Ron and I founded the company, we interviewed a lot of IAM personnel, security people, and we wanted to know how they deal with this problem. So we find out that the security is doing like audits and don't trust the IT and DevOps to do those tightening permissions, so they do quarterly access review or just investigate who has access to what. And on the other hand, this is the governance part. On the other hand, the way that permission were gave to the employee from the begin with were really manual. We saw and still see a lot of Slack, Teams, and even emails from employees saying, hey, I need access to that and that resource, and can you please give it to me? And we can see it when we try to have another meeting with a customer. Then we see they have all their calendars full of please remove David permissions from production. So before that, so basically this is what our company does. We created a one-stop shop where you can request permissions for cloud assets, and because we solved the provisioning part, the governance part is a byproduct of that. So that there were, as stated before, most of the breaches nowadays are identity related, and many companies and many vendors try to tackle those problems from many angles, doing like a UEBA for those identities, see odd stuff, but we say we can do that even a way simpler way. So the common stack for companies nowadays, the mature companies, if you're like a 20 people startup, you usually don't have this. But it's an IDP, a PAM product, and an IGA. Sometimes you don't have one of the or PAM or IGA products. And for the most common on-prem example or like large company example, it will be Active Directory or Okta and Beyond Trust as a PAM, and a SailPoint as an IGA. But throughout this talk, we will maybe talk about why we see that PAM and IGA are converging. So, at the beginning of the talk, we talked about that the legacy PAM products are doing the authentication and also the part of getting into the resource. Sometimes the resource is sitting in a private network and you need to tunnel to it, et cetera, et cetera. And some of those problems are not present in the modern cloud. Yeah, so this is exactly the point. If you want to connect to an old mainframe application, then you must use something like a jump server or a PAM solution in order to do that. But as we can see, in the cloud, most of those systems have the authentications built into them, and also the authorization. They have really fine-grained access management solutions inside those solutions. So you don't need to reuse the same password and put a jump host between the users and those applications. Authorization is still a problem. This is why we founded the company. And actually, the session audit was a killer feature for many of those systems because, again, everybody used the same users, so we needed to audit who did what in those systems. But when every individual user has their own permissions, then those audit trails can be part of the third-party system itself. You don't need to audit that with a jump server or something like that. Take a sip. So at the beginning, when we started our journey, we created a platform that basically gives users a self-service approach to access management. And we thought that this is going to be it. And our customers shifted us and saying, okay, now that everybody can get access really easily, we can just remove their access. And there will be zero standing privilege for those accounts. And when they will need that access, they can easily elevate it whenever they need. And so a lot of companies today are saying that you don't need to have your full admin all the time, and an Okta breach, an event like an Okta breach can have been eliminated if they had some just-in-time solution in place. So yeah, as we said, our solution provides a self-service approach. We have our own web UI, but we found out that companies don't want to put another portal for their employees, so they rather have the user experience through Slack or through Teams. And also Jira and ServiceNow are now coming. Most of the engineers in the cloud native world, they really hate to have another portal. But I assume this is also right for larger companies. So another thing that we find out is because of IGA and PAM products, what happened is that companies centralized all the access requests for the IT and DevOps. And then we created a distinction between who knows the asset best, which is the business itself, and who has access to it, the DevOps and IT. And what is happening is that an employee asks a request for something, and it gets routed to the DevOps and the IT. And they have no idea who is that person and what asset he is requesting access for. So they start their due diligence process, and this is not fun for any of the sides. So what we're trying to solve with our solution is, in order to centralize that into DevOps and IT, we make access management democracy, and we assign asset owners and application owners to those privileged permissions, and that way the routing is being done to the relevant person. And of course, you have like a small context who is the requester. So if someone from HR is requesting access to GCP production, that is something odd. Yeah, that's exactly it. Because we saw, basically what we saw when we interviewed the people that were provisioning those permissions, there were like rubber stamps in some cases. They didn't have no idea who that person and why they need that access. And giving them the context and reinforce them with a decision of what is this asset, providing as much data on that asset as possible, and of course on the user itself, makes that decision so much easier, especially when you can request this permission for a specific TTL. And you don't need to remember when to revoke it. You just when you approve the permissions, you can select for how long it will be. The user can also specify that as well. And you can also bind it to a third-party ticketing system. Let's say, as long as you're on call, or if you're assigned a support ticket, then those permissions will be part of your identities. And if not, it will be automatically revoked. Yeah, so as I stated earlier, the part of the democracy and also the asset ownership part took place really hard in our workflows, where companies really wanted us to make fine-grained workflows for the approvals, not just like have a approver group, but rather have the manager approval and some peer approval and etc. Things that are related only to the user itself, not only to the assets, because the business themselves know best. We cannot force them to have a dedicated workflow that we can predict for them. Yeah, so as we saw that we created this just-in-time access product, and people asked us, so wait, where should I put it? Should I do just-in-time access for everything? Or should I put it on the most sensitive asset that we own? And naturally, for permissions like the general Confluence page, everybody should have access to that. You should not JIT that. And this permission can be standing all the time. But all the privileged ones, you should, it depends of course on your risk appetite, you should be time bombing that as much as possible. So you can choose more lenient workflows for those sensitive assets, and for the less sensitive assets, you can just have them automatically approved, or manager approval can be sufficient. So this is to wrap things up. Basically, the term just-in-time access is something that our marketing team invented, but we are really proud of it. It's a way to combat over-permissions and try to get to zero standing privilege as much as possible. Thank you.
Okay, any questions? Raise your hand, nod your head. Okay.
Hello. This is really good stuff. So at my company, we've implemented just-in-time access for some of these critical systems like this, and we've run into some pain points. And I'm curious if you've also experienced these with your customers. One of them is that for critical systems, right, we'll say, production, high-level debug, right, I need root right now so I can go in and pull some black box information, right? Sometimes it's hard to get a hold of people to actually do the approval. And even if you have a group of people, right, it takes so long to communicate the context of what's going on, right? Like I have an active incident. Okay, I want to look at it, right? I need the number. I'm not just going to approve this, right? People get very tight-fisted about it. So I guess my first question is, have you seen that, with customers where when you move to just-in-time, it actually gets slower or more friction because when people need things, they can't get it right now because you need to wait for a human and then, this stuff stalls out.
Yeah. So great question. So first of all, we have some product things. I think it's echoes. Can you maybe turn off the? Okay. So first of all, in our product, you can have like multiple approvals, or you can also like ping it to an admin to approve it if not like the relevant approver is not awake or for any other reason. But actually, exactly feedback like this. We created the way that you can create a generic workflow for a specific asset. Let's say it's production. And if you are on call and you're requesting access for production for less than 3 hours, then it can be automatically approved. And if you're not on call, then it will go through this tedious workflow that you actually need to pull someone by the shirt to get access. So this is one of the most common workflows we have today. Production, if you're on call, you get it automatically. If you're not on call, read access can be approved, and write access goes through security and DevOps.
I'm sorry if I missed this in your talk, but the actual access management system, is it in the cloud, or can it be an on-prem device or system, or is it all in the cloud?
So at the moment, you can host it yourself. It's a Kubernetes deployment, but at the moment we are mainly offering a full cloud solution. But of course, this we prefer the on-prem. Yeah, I know. A lot of folks prefer it on-prem, but before they jump into this on-prem party, we are offering a hybrid deployment where you can have all the secrets stored at your end. We call it, we just put the connector at your side. And that way that the privilege permission that is used to change the permissions are not leaving your VPC, and we can only like send commands of granting people's permission.
Can you elaborate on that a little bit, sorry?
Sure.
Can you elaborate on that a little, please?
Sure.
About the second part.
So for the hybrid deployment, we have our control plane, which is in the cloud, and we have a connector that's sitting inside your environment. It's like, it doesn't need to have access to the web. It's doing like a reverse NAT, I don't know what's the name for it, and it's polling for tasks, and that way the permission, the sensitive credentials are sitting inside your tenant. So we cannot, like, let's say those permissions can read data, but because our connector is he's not able to read it, he can only like list who has access and grant those permissions, then we cannot read your data. It's basically the data layer is sitting at your side. We can only like see the metadata of what are the names of the assets.
More questions? Okay.
Hi, thanks for the talk. Could you expand on what IGA is and how it fits in with what you're doing?
Yeah, so an IGA, it's a general term for identity governance and administration. And those are like, I'm not sure if you're familiar with heavy duty IGA solutions. They're mainly doing segregation of duties, userly access reviews. They're doing more the governance side of of the house rather than the PAM products where they are doing the authorization and authentication to privileged permissions.
Okay. Then once again, thank you for coming.
Thank you for having
round
me.
of applause for that. We are quite early, so next talk is at 3 o'clock. We have 40 minutes. Next talk is Breaking Historical Ciphertexts with Modern Means. And that is one of the many talks that I've been looking forward to, so I'll see you back here at 3 o'clock. had a break now. It's time for our next talk. Absolutely a talk that I've been looking forward to. I've been interested in cryptography and so on for many, many years, but I failed at math, like really easy math in school. Never recovered from that, but I'm fascinated about ancient ciphertexts and the secrets they might reveal. So I've been looking forward to this talk all the way since it arrived in my mailbox. So we have Ilonka and Klaus, and please welcome them.
Thank you, thank you. So, breaking historical ciphertexts with modern means. And my name is Ilonka. I am a game developer and a crypto authority and a book author. My website is ilonka.com. And
hello, I'm Klaus Schmee. I'm a German computer scientist, crypto specialist, and I'm interested in the history of cryptography. And together with Ilonka,
we've written a couple books, such as this one, Code Breaking, a practical guide. So, introducing this, there are many thousands of old ciphertexts. Some have been broken and some have not. And the question is, can they be broken with modern means? So here's an example of one. This is an encrypted text by Emperor Ferdinand III from the 17th century. And here is one from North America. This is also from the 17th century. Here is the oldest encrypted thing we know about. This is from 1300 BC. It's encrypted cuneiform. Someone was encrypting the recipe for a dye.
okay, so we are talking about cryptanalysis today, and I'm sure that at least some of you are familiar with cryptanalysis, and maybe you even have some expertise in the field of breaking modern algorithms such as RSA or AES or DES and things like that. But cryptanalysis of modern algorithms is completely different from what we are covering today, because today we are talking about classical ciphers. So let's look at some of the differences. For example, okay, yeah. Yes, what? Okay, well, if you look at modern cryptanalysis, usually the algorithm is known, the goal is to determine the key. We are dealing with sophisticated ciphers, the plaintext is known or can even be chosen. We have an infinite amount of ciphertext, and the ciphertext can be easily read. Well, all this happens when you are dealing with modern cryptanalysis, but today we are talking about the classical case, and here everything is different. Usually the algorithm is not known, and the goal is not to determine the key, but the plaintext, and so on. So we have a completely different situation. Or to summarize this table, modern cryptanalysis and historical code breaking are two very different things. So when we're talking about cryptanalysis or cryptanalysis of old ciphers, let's start with the most simple case, the monoalphabetic substitution cipher. Monoalphabetic substitution simply means that you replace every letter of the alphabet with something else. So we have a stable table like you can see here. And the most simple case is that you not even have an alphabet change. So every letter of the alphabet is replaced with another letter of the alphabet, and this is how the encryption works. There's also the slightly more complicated case when the alphabet changes. So again, every letter of the alphabet is replaced with a symbol, but in this case, the symbol might be something that is not an ordinary letter, not an ordinary number, or can be even something you have never seen before, but it's still some kind of symbol or some kind of glyph. And from a code break, Sorry, I think I always click on the wrong button. I think it should work. From a code breaker's view, there's no big difference between these two cases because, of course, you can always replace the symbols you don't know with a symbol you know, and this doesn't change the encryption as such. Okay, here we have a Freemason document from the 19th century. In this case, we have no alphabet change because, as you see here, these are all ordinary letters. So it's a monoalphabetic substitution without alphabet change. On the next slide, we see another Freemasons document also from the 19th century, but this time we have an alphabet change because, as you see here, we have all these strange symbols. It's a so-called Freemason cipher, and these Freemason cipher letters look different from the letters we know. But as I said, it's a substitution in both cases, so from a code breaker's view, it's not much of a difference. And now the question is, how can we break such a simple monoalphabetic substitution cipher? Most of you certainly know how it works. Of course, there are several methods, but the most obvious one is frequency analysis. So if you know the language that was used, you know the letter frequencies. For example, in English, as you can see here, the E is the most frequent letter. It has a frequency of almost 13%, followed by the E, T, A, O, and so on. And this helps when we want to break a message. I can show you an example here. This is encrypted text from the 17th century, the so-called Winthrop cryptogram. It was created by an alchemist, so it certainly makes sense to break it because maybe it will tell us how to make gold. But before that, we need to know how to break it. Well, let's start with frequency analysis, and then we see that this letter that looks little bit like an 8 is the most frequent one, so could be an E. The second most frequent one is this one that looks a little bit like a J, and so on. And if we use the frequencies and do some trial and error, we can pretty soon solve this mystery. And it turns out that this letter that looks like an 8 is an E, and the second most frequent one is in this case an I. This is not always the case, so as I said, it requires some trial and error, but within 15 minutes or so, it's usually possible to break such a system without computer support. And now let's look what is written in here. Well, it's an alchemical text, take excellently well purified base salt, dissolve or malt it, and so on. Well, usually the content of such a message is not really interesting for the code breaker. So the code breaker is interested in how the encryption works and not in what is encryption, in what is encrypted. And I'm pretty sure that it won't help us to produce gold. Okay, now as I mentioned, something like this can be done by hand, but of course today it makes sense to use a computer program for this purpose. And in fact, a frequency analysis with a computer is not very difficult because there are quite a few programs around. For example, Multideck by Christian Baumann from Austria, or the Rumpkin cipher tools by Tyler Akins. All this is available for free on the internet, and just like CryptoCrack, created by an anonymous developer group. So in my view, the best tool for cryptanalysis of old ciphers is this one here, CrypTool. It's an open source software created in Germany. It has been around for 25 years. And meanwhile, it's a very good tool with a lot of crypto and cryptanalysis functions, and I use it a lot when I want to do code breaking work. CrypTool was developed by a team of over 50 people. Some of these are very active in the theme, so I know them well. And as I said, it's a tool I use quite often. So let's now look at another example of a monoalphabetic substitution cipher. This one is the so-called bearing gold cryptogram, because a British man named Sabine Baring Gould in the 19th century created this, wrote a book, and in this book a ciphertext is contained, and this ciphertext is usually referred to as the Baring Gould cryptogram. This is how it looks like. It's pretty short, only 2 lines, and now let's try to break it. Well, first of all, you see that we have an alphabet change here, because all these are symbols or numbers and not ordinary letters. So the first step is usually to create a transcript. A transcript simply means we replace every symbol from the ciphertext with a letter from the ordinary alphabet. How this is done doesn't matter, it just needs to be consistent. For example, you can see here there are 2 4s in this picture, and both of them should be replaced by the same letter, of course, otherwise you get in trouble if you do text statistics. But in this case we use a C to replace the 4, then we go on. There are 2 H's, again, there are 2 plus signs, again we should use the same symbol to replace these, the H in this case, and so on. And what we have now is the so-called transcript. So it's the same encrypted text, but now instead of an alphabet change, we have ordinary letters. Now we could do a frequency analysis, but this probably won't help because the text is too short. So we need to apply another method. And today this is no problem anymore, because today in the age of computers we have a very good method named hill climbing.
Well said. So now that we've converted it into letters, which is something that our brain can more easily munch, we do the system where we're going to generate a random key. And that generates a substitution table. And then we're going to decrypt it, even though it's going to come out somewhat random. And then we're going to rate the correctness. Now I'll come back to that later. Now we're going to create a new key that is slightly changed, again random, but we're going to keep the copy of the old key. Now we're going to decrypt with the new key, and again we're going to rate the correctness, and again I'll come back to that. And we're going to see, has the correctness increased? If so, then we're going to keep the new key and get rid of the old key. If not, then we restore the old key. And then we repeat the steps. And so what we're going to get here is we're going to climb a hill where we're steadily looking for better correctness. And often, when we get to the top, the best correctness, we will have the solution. Not always. Sometimes we get to something called a local maximum, where it looks like we've gotten to the top, but we haven't gotten to the top. And so this is called a local maximum. And there are ways of dealing with this. There is a system that's called simulated annealing. Annealing is a term for metallurgy, where they will heat metal, and then they'll kind of heat it and then cool it, and what they're trying to do is affect the properties of the metal. And with simulated annealing, you have a program where you're adjusting what's called the heat, and maybe you're going to have a fast or a heavy heat, or maybe you're going to make it cooler, and what you're trying to do is you're trying to get it off of that local maximum and all the way to the real top. And we could talk a lot longer on simulated annealing, but kind of outside of the scope of this. So, correctness. How are we rating the correctness? Well, in this particular case, we're going to check on the letter frequencies, and we're going to look at the candidate. Remember we said we had that random candidate, and we're going to look at what kind of letters are in it. And if it has frequent letters in English that are frequent in the candidate, then that would be a high score. Whereas if rare letters are rare in the candidate, that's also a high score, right? But if we're getting the plain text candidate and we're getting the rare letters are being common and the common letters are being rare, then that would be a low score, okay? So, looking at the Baring-Gould cryptogram, let's say, okay, this is one step, and so we're going to have our substitution table, our plain text candidate, the result, that score, and the step. We're only looking at successful steps in this case. All right, and then we go to the next step, and so forth. All right. So here at the penultimate step, we have a plain text candidate of a murd in the hand is worth 2 in the mush, which our brain probably, you know, a human brain, it kind of jumps on that, but the computer hasn't quite gotten it, and then it'll get to the next step. A bird in the hand is worth 2 in the bush, which is the correct plain text for this particular cryptogram. So many other monoalphabetic substitutions and more complex substitutions as well. All right, now we're going to go to a different system.
Yes. Now let's look at the so-called turning grill encryption. I think most of you have seen this before. These are original turning grills from the 19th or even the 18th century. I can show on this slide how this kind of encryption works. First of all, we need a plain text to be or not to be. And because this one is too short, I've added 3 X's for padding. And now we need to write this plain text into this stencil, starting with the first 4, then we turn the stencil by 90 degrees, and then the next 4 letters are inserted. And yes, well, I think this is a well-known kind of encryption, and it's a transposition encryption. That means nothing is replaced, only the order of the letters is changed. And now, what you can see here is the ciphertext. I hope you can see it even from the rows behind. Well, this kind of encryption was quite popular, especially in the 19th century, or even before. Here you see a few examples from the Netherlands or from England, from Italy. And of course, well, now the question is, can an encryption of this kind be broken? And the answer is yes. There are manual methods to break such an encryption. So already in the 19th century it was possible to break this kind of encryption, but it's very laborious. And so now the question is, can we use a computer-based method for this task? And the answer is yes, we can use hill climbing again. Well, it's clear that hill climbing can be used, but it's not really clear how well this works, or at least it wasn't clear until 2017, or at least I didn't find anything in the literature. So what I did is I created a challenge and published it on my blog. So I took a text, encrypted it with a turning grill, and a pretty large one, 20 by 20, and I published it on my website, and I told people to solve it. And so I was quite excited to know how long this would last, and the answer is it was pretty fast. So Armin Kraus, a German codebreaker, only needed a few hours to break this encryption with hill climbing. So apparently, if you have the right tools, it's quite easy to break it. And of course, if you're as good a codebreaker as Armin. The algorithm here is exactly the same as the one Ilonka explained. The only difference is we need a different scoring function, because letter frequencies are not helpful here, because as I said, we are dealing with a transposition cipher. The order of the letter changes, but nothing else. So the frequency of the letters stays the same. So we need something else. But what we can use is we can use letter pairs, or so-called digraphs. because the digraphs change, of course, and the digraphs are characteristic of of every language. For example, in the English language, something like th or en or er is quite frequent, while rare letter pairs are things like qr or cx or pf. So if you have a frequent letter pair, it gets a high score, otherwise a low score. And this is exactly how Armin Kraus, this German code breaker, broke this turning grill challenge. As I said, took him only a few hours, including doing all the programming. And this is the solution. Well, the solution or the plain text is not relevant here because it was a challenge. And the bottom line here is that even messages encrypted with a very large turning grill can be broken with hill climbing today. So it's certainly not a good idea to use this message for this method for messages that should be secure. And there are better methods available today anyway. Okay, so much about turning grill encryption. The next chapter is covered by Ilonka again.
Hey, nomenclators. So also I wanted to say I appreciate that everyone is in here because I know how hot it is in here, and especially with the masks, and I see the sweat, and it's like everyone's kind of melting out of their chairs. So thank you for sticking with this. So nomenclators. Klaus and I actually had quite the argument for our book on whether to include nomenclators. He convinced me. I have religion now. So what's a nomenclator? It's sort of a monoalphabetic substitution that also includes complete words. They're often proper names. And the term nomenclator comes from the person who would be, say, at an event, who would call out the name of people as they were arriving. And it's been around a long time. So here is an example, not an actual nomenclator. Say we're going to encrypt the phrase, "will come from London to Berlin," and we're going to use this table on the left-hand side. Some of the words we're just going to encrypt letter by letter. And sometimes, for example, for the word from, we're just going to put 2 digits, because that's from the table. Right? And then London, same thing. 2, we're going to do letter by letter, and Berlin, just 2 digits. Now here's an actual nomenclator table from the 17th century, and there's several different parts of it. Parts of it are just letters, and you can see there's actually 3 different choices for each letter in this table, so it's also got what's called a homophonic option. And there's also these places where you could take each letter followed by each of the possible vowels, and then that could be one of a couple different numbers. And then you have the actual names in this table, which are there, and then you've got 3 digits. So how do you solve a nomenclator message? Well, the simplest method is you find the table. However, that's not always possible. So there's different ways of doing it. You can derive the table from other messages maybe that have been solved. So I'm going to talk very briefly about the Zodiac killer. This is a serial killer in Northern California, and he had sent encrypted messages to the press and saying, if you can solve these, it'll give you information about who I am. And one of the messages was solved very quickly by a husband and wife team, Donald and Betty Harden. He had interested in ciphers, but she was more, I think, the intuit of the two. And between the two of them, they solved one of the messages called the Z408. We call that because there was 408 symbols in it. And then there were other messages that were sent as well. And you can see here from the 408 that it was also what we call homophonic, because each letter could potentially have multiple different symbols. Then there was the Z340, and this became one of the most famous unsolved codes in the world, and it remained unsolved for over 50 years, and then it was finally solved by a 3-man team using modern means, computers, including hill climbing. And then they published their solution in December 2020. And it was really interesting because they were on different continents, one from the United States, one from Australia, and one from Belgium. Jarl van Eyck, I actually just met him a few weeks ago. And Klaus and I refer to this as one of the greatest successes in the history of non-military cryptanalysis. I'm going to talk very briefly about how the 340 came apart. If you take the first 20 letters of it, and then you come down diagonally, sort of like a knight move in chess, right? And then you make a substitution table, again, the homophonic table. And the plain text in this is, I hope you are having a lot. And I'm not going to read you the whole plain text, because this guy was not all there, obviously. But they did clearly solve the message. And then that leaves two messages, the Z32 and the Z13, which are not solved yet. Some people say they will never be solved because they're too short. Others say, well, maybe it's going to include some combination of systems from the others. And some say that, maybe the Z13, the potential solution is Alfred E. Newman, who, if you're a fan of Mad Magazine, you'll know that character. So let's go over to a few other unsolved ciphertexts.
Yes, so this is the most or the best known unsolved ciphertext at all. It's the so-called Voynich manuscript. You might have heard of it. It's an encrypted book from the 15th century. It's handwritten and hand-drawn, and it has never been solved, so it's not possible to read it. It's written in a script that is otherwise unknown, and there are many pictures in it, and the pictures usually can't be identified. So there are a lot of plants in it, and it's not really clear what kind of plants this is supposed to depict. And this is clearly one, or maybe in my view, it's the most important unsolved crypto mystery in the world. But there are others, and there's especially one Ilonka is an expert in.
Give me a microphone. So my favorite is one that's called Cryptos. This is at the center of CIA headquarters, Langley, Virginia. And I've been kind of toying with this one for decades at this point. And some people say that this is one of the most famous unsolved codes in the world. And I'm not going to go into a great deal on it, but if you look at the plates that are on it, we have the ciphers that we call 1, 2, 3, and 4. And then there's 4, which is still unsolved. And it's 97 characters there at the very bottom. Now, the artist has actually given us some clues towards solving part 4. This is Jim Sanborn. And so in 2010, he said, okay, well, at this location, at the 64th character, we have the word plain text Berlin. And then he gave us the word right after it. This was 4 years later, the word clock. And then in January 2020, he gave us the word northeast, and then the pandemic hit, and so he kind of wanted to stir things up, and so he gave us another clue, which is the word east. So here we have a sizable chunk of the plain text from K4, and we still don't know what the whole thing says. So there's a lot of theories on K4. All right, and let's see, then we've got another thing that we've been working on. This is an encrypted postcard from 1873. This was sent to us by a man who found it in his family documents. He said this was from his great-great-grandfather, George Furlong. He was the owner of a football team, a football club in Luton, and it was a postcard that he sent to his sister. So we figured that it can't be that difficult, and we have these things that are underlined, but it's something that we've never been able to solve. And there are many, many more unsolved ciphertexts out there. So a lot of computer systems have been used on these, but they remain unsolved, so research is ongoing. So, conclusion, very briefly here. Breaking historical ciphertext is an active field of research. It's different from cryptanalysis of modern methods because, like, we don't have an infinite amount of ciphertext that we can work with and then try and figure out the algorithm. But the hottest technique that's out there right now is definitely hill climbing. And there are still many old ciphertexts left to solve. So, any questions? Yeah, how about, all right. He's going to hand the microphone right there. I saw a hand go up.
Yeah, I was going to ask if hill climbing works if like multiple rounds of encryption have occurred.
Okay, so you're talking about super encryption where you've got, will hill climbing work? It can. What have you heard?
Yes. Well, something like this happens, for example, when one tries to break Enigma messages. So if we're talking about an Enigma, it has a plugboard and then it has the routers. And doing hill climbing on the whole system usually doesn't work because there are too many variants. But something you can do is do 2 hill climbing steps. So first of all, do hill climbing for the routers, and then the second time for the plugboard. And this works. The difficulty in here is the scoring function. So it's if you have 2 different encryption steps, you need to tell if a text is good or bad based on an encrypted text. And this is really difficult, but depending on the system you're working on, it works, or at least there have been examples where this worked quite well.
Another way that super encryption and hill climbing might go together is you might have something that doesn't have a typical graph, a frequency analysis graph for a language. And so you're going to go through hill climbing and you're trying to find something that matches that graph where you've got a peak and lows instead of everything just kind of even. Yeah, good question.
More questions?
Are the techniques still effective if the languages have changed over time? So like frequency analysis on Old English, for example.
Sorry, I didn't understand.
Yeah, a little louder, please.
Are the techniques such as frequency analysis still effective for old languages?
You can take the mask off, just yeah, okay.
Are the techniques still effective such as frequency analysis on Old English, for example?
Yeah, yeah, doing frequency analysis. I mean, it helps if you know which language that you're dealing with. Like if you know you're dealing with English or French or German or Latin. And so sometimes, again, you've got that kind of trial and error. You're looking for which kind of a pattern.
What about languages that you don't know what the plain text frequency?
Languages where you don't know the frequency analysis. That would be really hard.
You have to make one yourself.
Yeah, you're building it as you go.
Out of curiosity, from my perspective, if you want to learn more about this, how do you get the interest into doing this kind of work? Any suggestions on where to ask, where to start on this? Any YouTube videos, any websites, any blogs? How do you start? And there's a book up front there by Elonka and Klaus. Yeah, so that's a way into cryptanalysis. Any more questions?
Simon Singh also wrote a wonderful book called The Code Book. There is a website called Mystery Twister where people will upload either classical ciphers or ciphers they've created on their own. And you can look and see each one, how many people have solved it. So if you want something easy, go to something that's got thousands of solves. And if you want a challenge, you want 0 solves or 1 solve. Yeah, Mystery Twister, yeah.
Yeah. More questions?
Do you know of any initiatives using generative AI to help on solving some of those?
Okay, has AI been able to help solve these large language models? In my opinion, no. When when OpenAI came out and ChatGPT, and I'm like, oh, okay, part 4 of Kryptos. I know it's 97 letters. I know we've got Berlin at the 64th character. And what I rapidly found out is that ChatGPT cannot count. And people say, oh, that's not true. I'm like, yeah, it is true. I said, just give me a sentence that's 97 letters long. It can't do it. You ask it 5 times, you'll get 5 different sentences of different lengths. So not yet, I think is my answer so far.
Maybe I can add something. The answer is completely correct. Not yet, but I know of research projects that try to change this. Well, at least in theory, it is very well possible to do all this frequency analysis and all these other statistical tests with artificial intelligence. I guess this will work well in a couple of years, because that's usually the first step. You perform frequency analysis and a few other statistical tests, and then you draw conclusions. So it could be a substitution cipher, or it could be a transposition cipher, and this is certainly work that can be done by artificial intelligence.
So does any of these techniques you've been mentioning work on one-time pad ciphers?
Well, if a one-time pad is used properly, no method at all helps, because it can't be broken. It's 100% secure. Usually, one-time pads have been broken before if the random sequence that is used is not really random, for example, if it's repeated. And I guess that things like these can be done or can be solved with the computer. It's probably difficult to do it with the methods we introduce, such as simulated annealing or hill climbing, because you don't really know what you're searching for. So that's basically the problem. Maybe AI could help here, because it could analyze a stream and then draw conclusions. Hill climbing probably not, would be my guess.
Or perhaps maybe just the XKCD strip of the famous XKCD strip, where you have 2 people saying, one person says to the other that blasted, they are using a 4096 bits key, we're screwed. And then on the next picture it says, well, we'll just use this $5 wrench and punch somebody in the head. And then we will get the one-time pads.
That's also a kind of cryptanalysis, not the one we cover in our talk.
Oh yeah, you don't have anything about physical violence in your book.
Yes, maybe we should include that in the next edition.
It's called rubber hose cryptography.
Yeah, or just interrogation techniques. They are very efficient sometimes. Any more questions? None. Okay, yeah.
Do you know if any of your methods to do cryptanalysis have been used to actually understand some of the languages, all languages that are not necessarily encrypted, but we don't know the answer? Is sort of like helping like Maya hieroglyphics that have been solved already, but some of the others.
Well, I have to admit that I don't know much about old languages. I know that there are certain relations between cryptanalysis and trying to read old languages, but I don't know anything about it. I'm a computer scientist, not a linguist, so I'm afraid I can't say much about this.
The main thing is that with modern means, we have the computers that can do the large databases and sharing this information around multiple continents, and that's definitely helpful. In terms of hill climbing, I haven't heard of anything, but for example, with nomenclator tables, often we have an encrypted message, so someone's gone into an archive, they have found an encrypted message. We don't know what system it is, we don't know it's a nomenclator or what, and so then the next steps are, well, what do we do? Well, we look at other messages near it, right? Okay, so those are nomenclators. Maybe this is a nomenclator. Does this one use the tables that these other ones did? Maybe, maybe not. There was a big discovery recently about messages written by Mary, Queen of Scots, where the table they didn't have, but they derived it from the messages that they had.
Okay, well, thank you, Ilonka and Klaus, for coming along to PasswordsCon.
Yeah. And thank you to you.
And there are a couple of books up here for those interested. I'm pretty sure you can ask about them. And we'll be back at 5 o'clock with Dwayne McDaniel doing the talk Long-Lived, Short-Lived Credentials, Auto-Rotating Secrets at Scale. So see you back at 5. Thank you.
Anyone that's going to DEF CON will have 2 talks there as well. Okay.
something spooky I do for you. I'm just trying to give you something.
I try my best to promote them as a band because they're that good.
Welcome back, Dwayne. Long-lived, short-lived credentials, auto-rotating secrets at scale. And please welcome Dwayne.
Thank you for that brief but wonderful introduction. Let me start my stopwatch here, and we'll begin. If you want the slides, that's the tiny URL. It's not that tiny, but I love tiny URL. Shout out to them for always giving me free, eternally living, short URLs because this is a Google slide deck, and I'm not giving you that entire thing. You can have it, but I'm not putting it on the screen. All right. Oh, sorry. I'll give you 1, 2, 3, 4. That's it. All right. So who in this room considers himself working in the world of DevOps? Awesome. Thank you for all of your work. Who in this room works in security? I originally had security team here, but I think we should all be on the security team. And we all technically work in security. So everybody's hand should go up. That was a trick question. All right. Who's on call right now? Really? When asked, I did the same talk in BsidesSV, San Francisco, and like 5 hands shot up. Like, I am so sorry for you being on call right now. But if you've ever been on call, if you ever had to incident respond, who has ever rotated multiple secrets because of an incident, like at the same time? Was that fun? No. Here's an example of somebody that had a really, really bad day rotating secrets, and the thing to pay attention to is this number. Because of the Okta breach, which I think, from this crowd, I'm going to skim over it. Attacker gets into Okta. They steal HAR files. HAR files contain credentials for customers. Again, super oversimplifying. Use those credentials to get into Cloudflare stuff. Cloudflare said, hey, we got this settled, don't worry. But they still got into Jira, which then got into Confluence, which then got into Bitbucket. And they're like, oh no, we missed one key, maybe 2. We'll still never know. Anybody from Cloudflare here that knows the exact story in chain of command, let me know. But 5,000 keys one day, that sucks. Oh yeah, I didn't introduce myself. I'm Dwayne. I live in Chicago. I've been doing developer advocacy stuff since 2016. I've been in DevOps space since 2014 and security for just about 2 years now. And I love security space. It's so much to learn. I love you all. I co-host a podcast called the Security Repo Podcast. We have everyone from Jason Haddix to Jason E. Street and a lot of other people not named Jason come on and be guests. And you should check it out. The link's there, but just Google it. We're the only thing called that. oh yeah, very briefly, I work for a company called Get Guardian. We have stickers up here. If you want stickers, that's it. We'll come up later in this talk.
I'm very, very sorry. This is not your fault because you didn't ask for this, but your esteemed track chairs both made outrageous speaker requests.
Okay.
And I need just 2 minutes of your time,
Sure.
if you don't mind, to deliver that to them. So is Cicely here? Okay. So you, I know kind of, first you just said no chicken in your speaker request. This is not chicken, so technically I'm fulfilling that request. But I received an unofficial request verbally afterwards that you could change that to be a cat named after you. So I have here a cat-themed sort of Wi-Fi war driving device that you can assemble. And I have named this one Seek Luan after Cicely Wan. Hold it up. Could you hold it up for her?
I could hold it up for her.
So some assembly required, but there are instructions online. I can help you find them if you need.
Thank you very much.
Okay. And then you, sir. I want to read specifically from the text because I was, you wrote, and I quote, "Surprise me, I know how this works. You cannot offend me." Okay, so I think I'm absolved of whatever comes after this. Do you agree? All right, still friends no matter what?
Still friends no matter what.
Okay. Here is your speaker request.
Run. Fucking run.
I won't make you put it on. Anyway, did I succeed?
Yeah.
Okay. Undefeated. All right. I'm very sorry. Thank you for the time.
Your turn again, Dwayne. Sorry.
Okay. I mean, you all can literally just go watch this on the B-side San Francisco. So if you'd prefer that and go do whatever you're doing now. Sorry. All right. I love how I didn't get anything, but another speaker did. Just pointing that out. Just pointing that out for next year. Feedback. It's critical. All right. The good news. Oh, yeah. So this happened. Just to remind you, if you haven't been paying attention. 5,000 keys. Need to rotate in embedded today. Oh, yeah, Get Guardian. We do secret stuff that'll come up later. I'll explain it then. We also do SCA, source composition analysis, but again, that doesn't really come up here. All right. We know how attackers behave. In fact, we know how they behave so much that we wrote it down. And we wrote it down in such a way that attackers read this and they know how to behave, which is kind of a weird paradox we live in. It's like when the Lapsus group, when Lapsus, like somebody said, hey, this is the Lapsus playbook. Guess what? We just made a bunch of copycats that now know the Lapsus playbook. So phishing is only going to go through the roof. Thanks, everybody, doing security research and being very public about it. But also the security research out there.
I'm sorry, dude. So this one's on you. So you put in a request for an outrageous request. Please accept this talk. So we have, for the very first time in Security B-Sides history, accepted a talk purely because the speaker asked us to accept the talk.
It was pretty outrageous.
Now, this is the first and only presenter ever invited because of his outrageous speaker request. Hopefully the talk is decent because we sure didn't read the abstract or anything. So, actually, that's all BS.
All right.
It's a great talk. We just, there you go. There's your certificate.
Well, thank you very much. I do actually appreciate that. That does make me feel
Good
a little
hack.
better about
Good
the
hack.
process.
That loophole has been closed now, by the way. So you're on.
All right, I'm gonna leave that there for pictures later. I'll pose with it. $5 a picture. I'll go out in the strip and do it there. Okay. point being, thank you security researchers who do tell us this stuff. I love Sophos so much. I don't use any other products, but I read the reports every time they publish anything. Last year, there was an interesting fact that popped up across all these reports that said the #1 root cause of all of our breaches are credentials. Exposed, leaked, stolen. That's for the first time ever, that the majority. And that wasn't just Sophos that said that. IBM says this. Verizon DBR said that. Actually, Verizon said 49%, but close enough. CISA said it's 54. Interesting enough, they said, Sophos said 17% are because of vulnerabilities. Theoretically, we're getting better at patching, or we're getting a lot worse at the credential thing. So attackers depend on multiple things in the MITRE framework, our attack framework, of your credentials working when they find them. If they find a bunch of garbage, they can do a lot of things with that, but they're expecting them to work when they use them. Otherwise, why would they try? So, I told you to come back. I work for a company called GetGuardian, and for the first prize of the day, you didn't know there'd be prizes, but for the first prize of the day, which is a surprise, who knows how many secrets we discovered on GitHub Public last year? And if you ever read this report, please let other people guess. And this is Price is Right rules, closest without going over wins. And we can look up the exact number if we get down to that. Who knows how many secrets we found on GitHub Public last year that were added just in the year 2023, just to GitHub Public. And by secret, I mean an API key, something that grants access to some other system. What? 10,000? Another. 2 million. 100 million. Other.
10 million.
$1, Bob. 50,000? 50,000? What? Million one? 475K? 40? I love that answer. That's a perfect answer for a lot of things, but that wasn't it. I think 10 was the I'm just going to cut it off there. 10 was the closest because it was 12.778 million. So you win a. Please pass that to her. You win an octopus that I crocheted on the plane out here. I like octopuses. Yeah, this is a shockingly disturbing number, to me anyway. But the biggest problem is this keeps going up, not down. In 2020, when they first published this report, which is a long story, another story I'll share with you over a drink, that's how I ended up working here is because of that report. We found 3 million, and then they found 6 million the next year, and then 10 million. That's not cumulative. That's just added per year. How we write this report is we're one of the companies that looks at every single new commit and every new is public event that hits to the API. It's a roughly 1 billion actions last year that we ingested, and we look for secrets. We send out pro bono alerts to all the committers if it's a working email, if they're not on a ban list, to say, hey, you did this, you should fix this, and we're trying to be good about it. We found in the research last year that we started looking for validation repeatedly. So the ones we could validate, out of the ones we did find that were valid, were still valid 5 days after they had been leaked. 90% of those. We're talking millions. You can go read the full report to figure out the whole breakdown. It's free, no sign up required. You can do it through an anonymous window in Tor or whatever. So, how did we get here? I ask myself this a lot. Whenever I'm looking at a problem, like, why did we do this? Because I believe behind every good problem, there's an engineer who had really good intentions. All you need to do is look at the UI on your phone and know that a developer spent a lot of time thinking about how their life could be better if they didn't have to program it. And then it's handed to a designer who messed it all up. But how did we get to the situation we're in today? I think it started here. We had these things called univacs and these giant machines that spread across rooms, and literal bugs were literal bugs. And how did we guard this? Well, the Navy was involved, thanks Grace Hopper. And we locked the door. We put a guard out front to shoot anybody that's trying to steal our secrets. And if then they can't steal our paper punch cards that have all our data. And they can't mess with the hardware to sabotage us. It's literally the beginning of the warfare that we're still experiencing today. This is why there's no difference between the civilian and national security sector, in my opinion, is because it's the same game. We've been playing it the whole time. Let's move forward in time a little bit to more modern era. I just discovered this the other day that Stephen Bourne, who wrote SH, his password was born. That blows my mind that the father of my favorite interactive thing used his own last name for a password. Anyway, but okay, we need to lock the door still. Can't mess with the hardware because these are all stupid terminals that are connected to a mainframe somewhere or a big Unix box. But the main use case we're trying to solve is stop users from playing Zork on company time because that's expensive. And sending emails from accounts that don't know. And that was a big problem at Stanford in the early days. Like you could just guess someone's super simple password and then hack your friends and have fun. And then the cuckoo's egg happened and it kind of got very serious very fast. Raise your hand if you've never read the cuckoo's egg. That is your homework assignment from me. I have several, but that is your homework. Go read it. It's a fun read. Clifford's a great weirdo, but he's a great writer. And then jump forward to the modern era, quote unquote, and we got this thing where any server in the world can be any machine in the world, and it runs these things called websites. And we have applications now that run on the web that anyone can access. All you need is an address and a browser. So, hey, TLS, SSL, great idea, stops the person in the middle attack, or the attacker in the middle attack. And passwords still work, right? Yeah, that's how I get in, that's how I admin. Still works. And then we get to this madness. Thanks, Click IT. I met these guys and told them I was using the slide, and they've never heard of me before, so I was very happy that I got to use their stuff. We get to this world of very complex interconnected systems. And what do? We threw passwords at it, but in the form of API keys and SSH keys and certificate authorities at best. Who works at a company that has dedicated PKI team? Good. I'm guessing it's a Fortune 100. That's what the numbers for CISOs say. This prevents unauthorized access to your machine resources, and this is good. This is what the goal is, to stop people from getting to your admin. All right, next prize. Guess, according to current research, how outnumbered we are humans to machine identities. Very quickly, a human identity is a human who has to do something to interact with the system. A machine identity is not a human who needs to interact with another system to do something. That's the definition I'm using. All right, any guesses? How what? Dead? What? What do you get? I can't understand what you're saying. Sorry, the mask.
Dead internet theory, I've never heard of it
No.
either.
All right. So I'm looking for a number because this is for a prize.
100 to 1.
Million to 1, 100 to 1. How much? 10 to 1. 10 to 1. 10,000 to 1. 50 to 1. Who said 10 to 1? Oh, I'll go there. Okay. Who said 10 to 1 first? You said it first? Yes. You won the other octopus that's much smaller because I ran out of yarn. Pass that back to her, please. And the correct answer, if we believe my good friends at CyberArk, and I love CyberArk for a number of reasons, they'll come up later too, it's 45 to 1. I think it's actually 46 to 1 according to the next update, which means for every 1,000 people that you need to identify within your system, there's 46,000 machine identities running around. And this is Kubernetes workloads. This is anything requesting a thing from another thing that's not a human. That's what that looks like. Just to put it in blunt terms. This is the problem we're dealing with today. We've heard a lot in this PasswordsCon, and I love that we're talking about it. Like, how do we secure this person over here? I think there's some good paths there. I do. Cracking aside, and all the ways you can mean that, this is the problem set. And I think what got us to where we are today isn't the way forward. We can't just keep doing this over and over again. Otherwise, there's no future to look forward to. It's just pure hell we're walking into slowly. So what do? First, I think there's these two things. Eliminate all credentials where possible. For some things, that's entirely possible. There's a way to do that through IAM rules, depending on your system, depending on how you're set up. I'm not telling you what they are, but there are ways to accomplish that. You can march down that path, but you'll always have the problem that eventually you need two systems to talk to each other that you can't just give a role to. Think Salesforce versus Google Cloud. Yes, you have to interact with those things sometimes. When humans are involved, there's these things called phishing-resistant MFA paths. YubiKey, biometrics, YubiKey plus biometrics, the most expensive of the YubiKeys, but they work awesome. I love my computer because it's an M2 that I can have a fingerprint and it opens things, and with one pass, I can do all sorts of crazy things with just my fingerprint. And then the last one, if you do have to use credentials, let's rotate them very, 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 very fast. I got quoted in CSO online a few weeks ago on an offhanded comment I made to the reporter. It's like, humans hate changing their passwords, but machines don't care. So we should be changing them a lot faster. he left off the last part, so it's just machines don't care. And I'm like, oh, okay. That's what I think. And this is my opinion from here on out on this point of view, and you're welcome to argue with me out in the hall. But I think we have a clear path for humans overall, and it's called MFA. It's called ID verification. First talk of yesterday talked about that deeply. For machines, it's a big old question mark sitting out there right now. So instead of going down and talking about all the question marks and the ways we can solve this, I'll get to that later, I promise. I'm gonna talk about what we do in the meantime. And that's the auto rotation, because that's something achievable, that's something people grasp. That's something other people in this room have given talks about. Thank goodness. Other people are talking about this out loud. And I think it boils down to just do these two things. You just gather all your secrets into one secrets manager, and then you set an auto rotation policy. And I realize that's like telling you how to fly. Just don't fall down. I think thanks to ChatGPT for making this really stupid, weird image. The longer you look at it, the weirder it gets. Like, what are those birds? What is that? What is that? Anyway, so word of caution before we go any further, because I've had somebody at another talk say, hey, I want to go do this, and that's like my full-time job now. I'm like, no, it shouldn't be. Don't boil the ocean with this. You're gonna have to go step at a time. In fact, I think you should go bird by bird. Again, if you've never read this book, read it. Nothing to do with our field, but it's such a great book. If you're gonna write a book about birds, how do you do it? You go bird by bird. It's that simple. So you go secret by secret. So you gotta make a plan, and that plan is gonna involve multiple things, and this is what I think you should be asking. The first is, who owns this approach? For the third prize, which is not hand crocheted, I promise, it's something cool. Who knows at what revenue level your average company has a full-time IAM person? Like, that is their job, is we handle IAM for the corporation. Enterprise, I'll use the word enterprise, not corporation. For the enterprise, I have a dedicated full-time, I report straight to the CISO, and this is what I do. We make IAM happen. What's the revenue line? What? 100 mil? Other guesses?
Double Down Saloon.
Double Down Saloon? That's not a number, but okay. 50 mil? 40? What? 1 million? 1 billion? That's the last one back there. 250 million? I'm going to go close without going over. I don't have it on the slide, but this is IAN research from RSA. It's $5 billion before a company's big enough. So I'm going to not throw this because I will come up and get this later. This is a Frisbee. Because I'm going to hurt somebody. This is hard plastic. This will hurt somebody. So come up later, get that. It's yours. So you got to have somebody that owns the approach. And we can't wait till $5 billion. We have to get this now. We have to get a jump on it right now. But someone has to own this and spearhead this and be like, this is the thing. And be the voice in the desert saying, this has got to get done. This is what we got to do. We're going to shepherd this through. This is the vision. We're selling it. We're doing it. We're loving it. Could be your CISO. Could be your CEO. I hope it's your CEO. I would love to meet that CEO, though. Second, you need to ask if your organization is mature enough to do this. If you were 2 people that just started on a prototype last week, maybe not. If you are a team of 50 that have a product out in the market for 2 years, you're late to the game. That's what I think. But I think there's a map for this. That's what the talk I gave last year, and that's what that link goes to, is that talk. Not that talk, the research is based on the secret management maturity model. Something we came up with at GetGuardian to try to evaluate how people are going from, all my secrets are just everywhere, willy-nilly, to, oh, this is how professional enterprises with 20 to 30,000 developers deal with this day to day. And we help people figure out their place in that map. Will your devs go along with it? This is a question you have to ask. And if the answer is no, maybe you need another company, because that's a culture thing I don't know how to fix. This is Dora Metrics 101 stuff. This is like, I don't know that one. But there has to be a path for them, and I'll talk about the path I think is appropriate. And then you got to ask, where are our secrets? The first rule of API security is knowing you have API. That's it. That's the first rule. If you don't know how many APIs you have and how many endpoints you have, you'll never be able to secure it. All right, so let's make a plan. The only actionable one on this list I'm going to talk about is the last one, because let's assume you got all the buy-in. Let's assume you figure out the path. We'll talk about 3 a little bit, but let's just figure out that we got answers to that. We got a path. We got a vision. First is we're going to gather all the secrets into one manager. This is an oversimplification. and the full extent of my artistic ability explaining what a secrets manager is. Developer, instead of writing their secrets to the specific thing they're writing, they write it to a secrets manager and then call that secrets manager programmatically from the thing they're writing. That's it. Whether it's to get data, whether it's whatever they're doing, but that's how it authenticates. That's how it do auth-in/auth-z with it. Oops, sorry, the wrong way. So the basics needs for a secret manager, in my opinion, and the research in the industry right now is it encrypts data, it encrypts your secrets at rest and in transit. Very important. If you can't do it over MTLS, don't do it. Well, I guess you could do it whatever you want to, but as long as it's encrypted in transit. It's available across all environments. This is hard. This is one of the hardest things on this list. 3, centralized reporting might be the most important one on this list. If you can't keep track of it, you don't really got a vault on your hands. You have a list that you lost track of. And it's got to be easy enough, again, for developers to say, oh, I can do that. That's pretty straightforward. In fact, that's easier than what I've been doing. Good news, if you're all in on a cloud provider, like you are 100% AWS, there's a great solution for you. It's called AWS Secrets Manager. If you are 100% on Azure, it's called Key Vault, which has great documentation. I'm going to give them credit where it's due. Secret Manager from Google Cloud, you're going to have your own experiences with, but it's still there. It's still good. If you're 100% in it to win it, and this is all you do, this is your answer. If you're in multi-cloud, that's where HashiCorp Vault comes in. This is where CyberArk comes in. They make a thing called Conjure, among other things they make. Achilles, I love those people. Doppler from Down Under, they're from Australia. They are a wonderful company to work with. If you see them, go up to their booth, and they're great people if you ever at an event where they're there. So that's the secret manager I'm talking about. So how do you use these? If you've never used a vault before, has anybody in this room never touched a vault before? Okay, I can skip this part. You basically give a path to programmatically call something out of the vault. You put it in the vault programmatically. There's keys. I'm not going to explain all the encryption here because I don't have that much time. But you basically put a secret in it. You call it out programmatically. So instead of writing the hard-coded secret, you write this and you pull the secret out. It loads it in the environment at runtime, and you're good to go. So which secrets do you put in? Again, we're going to go bird by bird. Which do you focus on? New secrets are an obvious win. Hey, we got a brand new project. Great. Greenfield is the best place to do anything. But in all reality, we don't work in greenfields most of the time. So what's your crown jewels? What are you guarding the hardest? If it goes down, where do you lose the most money? That's how I think of crown jewels. Walmarts.com support portal for customer service can go down for several days and they'll be fine. But if their actual payment gateway goes down, then that's bad. That was a joke on Walmart's part. Anyway, legacy secrets should go next, and then zombie secrets are last. What are zombie secrets, you ask? How many people know all the secrets that you have, all the passwords for your entire company and for every system you've ever turned on? How many know how many systems are even running in your environment? Yeah, those are zombie secrets. So how do you find your secrets? You write an email to your all company and you say, you list all your passwords in plain text in an email. Obviously don't do that, that's stupid. So how do you actually do this? Well, there are tools for this. I work at one of the companies that founded this industry and built this stuff. GitGuardian, but Truffleog's open source, they're awesome. They also have an enterprise product. GitLeaks, the person who invented GitLeaks now works for Trufflehog, so is it still maintained? That's a question. But awesome products. Again, I'm never going to say anything bad about open source because they're doing awesome stuff in the open source world. There's other companies like PingSafe, and there's other people that do this. But PingSafe was just the first one that came up on who competes with these two. All right, so we scan and we find all the secrets, put them in one place. I'm not going to sell you on the virtues of one approach or the other, but eventually they're in one place. A platform, a list, somewhere. Okay, we got them all. We found them all. Now let's set an auto rotation policy. The script logic needs to work simply like this. You need to create a new secret for the one that's in play. Test that new secret will actually work through some kind of method. That's optional, but highly recommended. Swap it in for the new secret. Make sure that nothing broke, and then clean up from the internal, or clean up from the step. Basically, blue-green deployment. Hey, there's the blue one. Green one's right here in case you got to roll back. HashiCorp Vault has this as a built-in button. We got to roll back. Bam, we're done. In fact, yesterday there was a whole talk about this exact thing that you can go find online right now that will talk way more about the details and the specifics of how to do this properly than I can possibly get into from this higher level talk. So perfect. Thank you so much for giving this talk yesterday, Ken. And go ask him if you have specific questions about implementing HashiCorp Vault, not me. Set you up for success. All right, so if you're all in a cloud provider, this is actually really easy to do. In fact, where I got this list from was reading all the scripts from AWS and how they do it. This is their formula, but all the formula is the same. It's the same cake you're baking. Order of operation, where the testing goes, A, B, C, like whatever you're labeling them, that's gonna vary. But again, if you're all in 100%, here's a path for you. It's pretty straightforward. In fact, they wrote it for you. You don't have to do anything. You just like, go pull this, throw it in the right field, and you're done. You gotta name some things, but obviously you're not 100% done, you're 80% done. Hooray, if you just wanna go see how this works, again, all open source, you can just go look at this all day and study how they did it. Multi-cloud is gonna be a little bit rougher because now you have to figure out if there's a way to update or request a new secret or even interact with the secrets from the APIs. For most systems, for most modern systems, there better be. And if there's not, you call them and say, you give me this or I'm going to your competitor that has it because this is mandatory for the future. And then you have your Vault system interact with that system. This is why I like CyberArk, because Conjure does this. They have a path to call external APIs to trigger this. Circle CIs looks like that, Slacks looks like that. Doesn't matter how you call it. These are just trivial examples. The idea is the more important thing here. And then I think there's a world where we can tie all of this stuff together really well. And that is we use the secret detection tools we already have, and that's how we found in the first place, to further automate the process. So upon discovery, because you should be constantly scanning for secrets, it's not a one and done thing. It's not SAST where I'm scanning for vulnerabilities right now in this version and we're good because we won't add any more problems, right? No, this is every new time you touch the code, we gotta remake sure that no one put a plain text secret here or did something that will expose a secret. So let's find any secrets. And then let's go check if they're in the vault. Might be. Hopefully they are. If they're not in the vault, let's put it in the vault. And here's the part that's a little bit tricky, but why I think it will work with the developer. So let's go ahead and change the code. Let's go ahead with scripting logic to say, if we're calling a password to this system, here's the exact call that would look like if we were calling it in Vault. And let's go ahead and make the PR. That's a lot of logic, that's a lot of steps. I oversimplified there, and I'm realizing now that should be 3 slides. But again, when you write your talk 3 minutes before you get on stage, you forget things. And then eventually you rotate the secret. But this is possible. There's a great language called Bash, based on this thing called SH, which a guy used his own last name as a password in, which is weird. But it still works. Bash is universal, it's true. Python works too, I guess, if you like Python. But if it's true that you found the secret and it's already in the vault, well, you still need to make the PR to replace that line of code, but now all you gotta do is update the secret. You don't need to put it in the vault. You just like, oh, this is probably already accounted for somewhere. Let's just call it. Hooray, we rotate, we win. And if you're thinking right now, who on earth would do this? We did this, minus the auto PR step, but again, that's a scripting lines you need to modify based on your specific setup and needs yourself. But we got the rest of the scripting and logic for you. It's called Brimstone, is the thing we ended up calling it. The actual GitHub repo, which is linked if you click that, is a really long name that CyberArk came up with, but ultimately Brimstone was the name we all settled on. Brimstone, and I forget the name of the thing it's built on. But basically, Brimstone's the last thing. Yeah, it does this. Auto find with us, communicate with CyberArk. A lot of steps in here. And right now, you probably are thinking, like I was thinking when I saw this, oh, and there's a full demo of this. This isn't vaporware. You can go do this right now, but you can also watch the videos of how we did this, and it's all open source. Like Brimstone itself is open source. You can dig through and see exactly how the calls are made and how we're accounting for the fact that we can't communicate or shouldn't communicate a plain text secret over the wire between 2 systems. We've already thought of that, don't worry. This involves hashing and fingerprints and a lot of backflips. But if you're like me and you think, this is a whole new level of middleware I gotta run. Wow, That's brittle. Who's going to maintain that? I don't disagree with you. This is possible, though. This is this current where we go next. But it's not where we're going eventually. It's how SBOMs are a step in the right direction, but they're not the final point. This is our next logical, I can't possibly do the thing you're about to talk about next, but I can do this, and we can get here, and we can get here, we can get there, I think. Because I think instead of all this, and hear me out, PasswordsCon, we just accept that credentials, the way we've been doing them, are a terrible way to approach machine identities, just fundamentally. We made a mistake 40 years ago, 30 years ago, when we started having two servers talk to each other and need to identify that adding a password in the mix was, especially a long-lived password that never rotates, was a terrible idea. So what do we do instead? Welcome to the world of Spiffy. I love the Cloud Native Security Foundation. I love OpenSSF. I just spoke at Cloud Native Security Con like 3 weeks ago, or very end of June, so wow, we're already in August. The very end of June and back in Seattle. And there's so much excitement and wonderful motion happening around this world. I'm gonna oversimplify it because, again, I'm almost out of time. But imagine a world where everything just gets a namespace that can be checked by a federated certificate authority system universally that says, yeah, you're you. Here is a cert that lasts just as long as your request. Oh, you can't do it with a 509 cert? Here's a JOT. Not as good, but here it works. Hey, you can have the request. As soon as the request is finished, bam, it vanishes, it never existed. Anybody finds it, it's useless. All you know is what certs look like and what a JOT looks like and when it expired, I guess. Spiffy is secure production identity framework for everyone, invented for Kubernetes by people that built Kubernetes and expanded out to the whole rest of the world. Spire is the implementation. So if we think of OAuth as the set of ideals that we should be chasing and why it's not a proper framework, you can think of OpenConnect ID as the thing that you implemented. Spire is the thing you implement. They're both open source ideas. I didn't put them on the slides, but there's companies doing this now as a service. Istio is the one that jumps to mind. There's others. They're just the first one I'm going to name. For the sake of time, let's move on. Oh yeah, so this is what it basically does. Yeah, again, I'm just reading a website to you at this point. But the important thing is that you can have one central certificate authority that might go down, might be unreachable, or you federate this across everything and you sidecar this in the world. And this just becomes how we think about this. From a developer standpoint, this is one extra line of code they need to throw in and never have to think about a password ever again. It just magically works. And that's a promise that I've seen fulfilled on stage. I watched someone implement MTLS by hand on a talk that's online from Cloud Native Security Con. Implement MTLS by hand over the course of about 10 minutes, painfully, and account for it on all the clients. And then she did this, and 3 lines of code later, magically MTLS for every communication. There is a much, much, much better talk than what I just gave about it from Cloud Native Security Con this year. That's the link to it. Highly recommend you watch it. This is the most entertaining talk I've seen in years about the story of Crush and how he identified and how he talked to the Postgres squid and like they used under the sea whole thing. It's beautiful, but it explains the concept brilliantly in the future. The problem, I think, with it, and this isn't really a criticism, is that they live 3 years to 5 years in the future. The people building this. They kind of do. I love them, and they're going the right direction, and they're telling us where we can go next. But I don't know a lot of companies that can jump to this right now. Small companies, new projects, absolutely. This instead of building the other thing I talked about. You're an enterprise, this is where you're eventually gonna be headed. Search for everything, PKI everywhere. IAM run by a team that's not security, because it's IAM. So in conclusion, this is where I wanna be at 3 in the morning. I wanna sleep there. I wanna be not worried about someone breaking into my stuff, or that a password got stolen, or that someone got in because of a password. All we gotta do is gather all your secrets into one place and set an auto rotation policy. That's all we gotta do. I know that's all we gotta do. That's all we gotta do. I know it's like saying, just don't fall down. Just don't fall down. But we can do this if we don't try to boil an ocean. We can just do it bird by bird and think, how am I gonna deal with this secret and make sure this one doesn't leak? And if you only do 1 secret a week, that's 52 secrets you do in a whole year. Maybe 50 with vacations. That is so much better than where we're going right now. It doesn't keep up with it, so hopefully you'll go a lot faster once you figure out how to automate things. But start small, and it leads to very large things. Eventually, this is where I think we're going. But we can't jump here, I think, for the most part, because of the way enterprises work today, and the fact that not all services agree on this, and not all cloud providers agree on this. But Conjure and CyberVault and HashiCorp's Vault both do. You can use that as a springboard to get here. I left that part out earlier. Sorry, I got a little out of order. Anyway, I'm Dwayne. I live in Chicago. Check out the Security Repo podcast. We have all sorts of great guests. And if you weren't, I loved karaoke. I did karaoke last night. If anybody wants to do karaoke tonight, we'll make it happen. And with that, yeah, I'll open up for any questions. And that's where you can get the slides.
Questions?
I'm sitting here and going back 20 years in domain administration and going, okay, that's nice in the sense of getting to 1, but realistically, when you're talking about passwords from everything from routers to switches to laptops to laps, all the domain admin crap that you need to deal with, and the legacy crap that's still in all of our environments, how do you handle that to 1, or do you go to 2 or 3? What's the theory on that?
1 to 2, 3 what?
Meaning, I like if I stand up and, okay, here's my experience. New organization startup, born into the cloud, adopts this from the beginning, totally perfect.
100%.
Organization's been around for more than 20 years. They have a legacy AD architecture that may be halfway split into Azure AD, but you've still got, think of what happened with CrowdStrike.
Yeah.
The local password was the issue for people being able to get into that machine, and you use something like Laps to constantly rotate that, but that's not centralized into the Azure AD or the secrets manager within the cloud. It's actually still a one-off credential that is out there. So I can use 1 for my cloud environment, but for the rest of this, how do we handle that?
Well, that's where enterprise vaults really come in. And something that somebody at CyberArk, I forget his name, Evan, I can't remember his last name, CyberArk said in an interview I did with him once, I'm not telling everybody to put everything in CyberArk, and we are the be-all, end-all, but you can coordinate through us to have a view into everything. And if you can get to there where you know about everything and everything is centrally accounted for, that should be where we're marching to next. That's why that's first, is let's figure out what we have. So it's hard. So one of the problems with Spiffy right now, Inspire, the way it exists right now, is Postgres can't account for it. You can give it a jot, but that's janky at best. But it's Postgres we're talking about. How much of the internet is Postgres right now? So this isn't a solvable problem. I have a simple pat solution for you, unfortunately. But those are the conversations that are driving right now. And we're trying to solve, I'm not trying to solve them, but the people that are building the stuff are trying to solve it. There's not a great answer for that, other than if your vault systems can't account for on-prem, cloud, and all your endpoint devices, you need to have a conversation with somebody that builds vaults, that makes those. HashiCorp would love to have that conversation with you. I'm on the other end of it. I'll help you find your secrets wherever they are. If you got a log, I can find it.
Any more questions for Dwayne?
Sir.
So I'm going to ask you a question that we had to deal with on our side, right, as evangelists of this. And I have a solution that I don't know how well I like, so I'm curious what yours is. So no matter, once you collect all of your secrets, right, you're going to find some stuff that is just for crap applications that never thought anyone would ever want to rotate it using an API, right? So the only way for you to get in and change it is log in as a human and do a 2-factor push and click through 5 shiny UIs, and eventually you press a button that regenerates something, and you got to copy that out. How do you deal with that? Or credentials of that type that are just not suited to automation when collecting them in a vault and trying to rotate them?
I wish there was a good answer to that other than business case. if it's a crappy service that's not being used or being used in one place, that's a bad business case for using a tool. If there's a clear cloud provider solution that is modern, that you can hit with an API endpoint or hit an API endpoint and do everything you need to do, that is comparable in price, what's the refactor cost? At some point, and this is the truth, every business needs to roll the dice and say, if somebody took this over, we would lose $5. I'm okay with that. If someone breaks in and steals our crown jewels, our company goes away and we all lose our jobs. Those are the very end extremes. The other example I like to use on the low end is a folder full of cat photos. Sure, I want everyone on the internet to see that. I don't care what the password is. I don't care if I can rotate the credential. I don't care. And that's it. You have to care. And I don't know what your business cares about. So that's why it's a hard question to answer. But you're describing a world with ClickOps, and we got to get away from ClickOps. But that's a whole other discussion in DevOps. ClickOps is dead. It died years ago. It just keeps lingering, and Microsoft community keeps it alive.
Okay. Question? No. No questions.
Yeah, one last one.
One last
We're
one.
out of time.
Yep.
And I'm sorry, it's not a question. It's more of a Jeopardy answer.
Okay.
Clifford Stoll, the author of The Cuckoo's Egg,
Yeah.
now runs this topological business out of San Francisco.
Klein Flasks.
I didn't even get to do.
Oh, I'm sorry. I broke it for you. Yeah, Clifford Stoll, out-of-work astronomer who got a job and tried to track down 75 cents in discrepancy at a time when it was $300 an hour to rent the machines.
It's an amazing book. Don't
Amazing
reveal
book,
the
but
secrets. It's an amazing book.
His current business is selling Klein Flask, his largest collection of Klein Flask in the world. They're one-sided objects. They're amazing.
It's like a three-dimensional Mobius strip.
Yeah.
And it's worth buying one just to get the page of jokes that comes with it.
I've never bought one.
You have a page of
I'm going to buy one today. I'm buying one today. Oh, I want to see this. I can probably find it online, but I'm gonna support Clifford Stoll other than just reading his book.
It's freaking amazing.
And also,
yeah.
if you're like, I do not want to read a whole book, one, read the book. But two, there's a Nova special from 1990 starring Clifford Stoll called "The KGB, the Computer, and Me." It's free on YouTube, and it's all the people, the actors, like every actor or actual person they could get from the real world that experienced this, that's in the book, they got to be in the Nova documentary. So you're like getting to watch like real history unfold. It's amazing.
And do you also know that in Germany they made a movie about that thing seen from the hacker's perspective?
And they make movies outside of the U.S.?
That does exist. Yep.
I'm an American.
If
I
you
don't
have
know any of
ever heard the phrase torrent, you might be able to find it.
Pirate Bay shut down, man.
Did
I
I
don't know
say
where to
that
get torrents.
on YouTube? Oh shit. Okay. Yeah. Well, okay. So anyway,
All right,
thank you,
thank
Dwayne.
you very much.
Yep.
Enjoy the rest of your B-sides.
And the last talk for He's a friend, he's a former colleague of mine, and he's also a co-conspirator in crime, maybe. We have been doing a couple of projects together, and he's just friggin' amazing pen tester, and I'm looking forward to his talk. So no pressure, John, and take it away. Please welcome him with a round of applause.
Thank you, thank you. Maybe I need to get a little bit closer. Welcome to my talk. I'm glad and surprised so many showed up, especially since the last one on this track. This is my first talk in US, first talk in English, so please bear with me. This talk is named All Your Badges Belong to Us, and my name is John Andre Bjørkaug. I'm Norwegian, working as a penetration tester for a Norwegian company called Net Security. I'm originally educated as a electronic engineer with specialization in wireless systems and telecommunication. But it's much more fun to break stuff than building stuff, therefore I do penetration testing instead of engineering. I've been doing penetration testing for 16 years, focusing on everything from internal testing, web apps, physical testing, social engineering, and so on. Small disclaimer, most of the stuff in this presentation is not new. Most of it is already known, but it's so stupid and everyone should know, therefore I'm giving this talk. Nothing of what I say represents my company. It is my meanings and feelings. PACS, P-A-C-S. Does anyone know what that acronym stands for? No one?
Personal Access Control System?
Close.
Programmable?
Proximity Access Control System. Most, I hope, have seen readers like this and have cards like this. If you haven't seen anything like this before, you should go out from the rock you're hiding under. I made this sketch to try to explain how an access control system is built. Starting on the right for you, you have the token, the badge, which communicates with a reader, either on HF 13.56 megahertz or 125 kilohertz LF. When you take your card against the reader, there is an RF signal charging a capacitor in the token, acting like a battery, giving power to the microcontroller, which again makes the communication between the reader and the token possible. The reader communicates either wireless or wired through protocols like VGAN or OSDP to a controller. The controller has the entire user database, and the controller is the one doing the authentication. The controller also communicates with the door and open the doors if the token is valid. The controller talks to a server, which has the user interface, the user database, and the configuration. The server also in many cases acts like a client. It's where the software is installed and all the users added to the system. And in many cases, this is a standalone system, not connected to the local network. It's not connected to anything in many cases, except maybe internet, because the vendor need to have access via TeamViewer to do configuration. In some other cases, you might have the same over here, but the server, and you have several clients with the application running on it. And the server and the clients might be joined to a domain. So if an adversary is able to compromise the domain, he also have compromised the entire access control system, which I have done in several penetration tests. We were able to dump the entire database and create our own cards. I mentioned earlier that you have HF and LF tokens, high frequency and low frequency. So I made this slide trying to explain the different technologies used, and also saying which of the tokens are possible to clone easy and which is considered secure. MyFree Classic, I guess many of you have heard about MyFree Classic tokens, MyFree Classic cards. NTAG, HID, iClass, and iClass Elite is really easy to copy, to clone. MyFair Ultralight, MyFair Desfire EV1 is considered also possible to clone, but it's a bit harder. And the green ones, Desfire EV2 and EV3 is considered quite secure. EV3 is what is recommended if you're going to have a MyFair Classic, MyFair installation. And the low frequency cards, you have like HIDprox, EM, Avid, Indale, EOprox, EMR in Viking, and a bunch of others. They have no security. There is a few exceptions. Someone has tried to make some password thing there, but no one is using it. So if you have any LF cards, it's really easy to clone them. MyFree Classic, a little bit more details on them. And Per, you asked us to have some kittens, if there are some slides with just information someone might know, so I included some ChatGPT generated kittens. The MyFree Classic is an invention from the mid-90s, so it's not so old. Well, maybe it's getting old, but yeah. It was originally Philips, the Dutch company, who made MyFree Classic. MyFair was later turned into, moved over to a company called NXP Semiconductors in 2006. It was a proprietary encryption, so it should be really secure, or maybe not. In 2007, 2008, Karsten Noel, a really famous security researcher from Netherlands, together with some other people, were able to crack the MyFree Classic algorithm. In 2011, there was an update with backward compatibility. That was cracked in 2015. In 2015, NXP also recommends that no one should use MyFree Classic afterwards. The picture you can see here, I took during a penetration test last year, and that was a system installed in July last year using MyFree Classic, which was recommended in 2015, never to be used anymore. So you should use more secure cards, like for example, Desfire EV3. This installation also uses only the UID on the card, which I will come back to later. More details on the MyFree Classic. The data on those cards are divided into 16 sectors. There's 4 blocks on each sector, and the first block or the first sector has the UID and some other information hard-coded. So it's not possible to change the UID on a regular card. And all sectors has its own encryption keys, 2 keys, one A and one B key. Both of them are 6 bytes long. If one of these keys are known, there are some attacks called nested and hard nested attack, which makes it possible to get all the other keys on the card. And on many, many, many systems, there is at least one default keys, which in many cases is FFFFFFFFF, which is the default encryption keys. So if, for example, only one sector is used and it's password protected, but all the other sector has the default FFFFFFFF, it is possible using nested or hard nested attack to crack it. Default keys. No one uses default keys or default passwords anymore. Per?
Nobody.
No?
Absolutely nobody.
Yeah, that's good to hear. In 2014, I worked for a company in Norway. I got my access card to the office. I had a reader, ACR 122, if anyone has a reader like that, really good reader. I cracked the keys on my card because I was curious. I hadn't done any work with RFID before, so I just wanted to try it out. Cracked the keys, put those keys into my Android phone with the app MyFur Classic tool. And just to show my colleagues, hey, it's so easy to copy the cards, maybe we should talk to the people who owns the building and maybe make them change the system or something. But a couple of weeks later, I was doing an internal penetration test for a customer of mine. And during lunch, I saw that he had this card hanging around his neck, and we started to talk about access control, and I was just curious, can I just try to read your card to see what kind of technology is used? And to my surprise, I was able to dump his card, and I didn't understand why until I saw that I accidentally chose the dictionary with the keys from where I worked. So it turned out that I was able to dump his card from a totally different company, totally different building, using the keys from my office. So I started to do some research, talk to people I knew, found some people who had the same access control system. We tried to dump those cards too, and we found out that all cards were using the same keys. All the systems had the same A and B key. And I talked to the vendor, and they said, yeah, they use the default keys for all installations. It's easy. The system came hard-coded with them, and it was impossible to have control of different keys for all their customers. Therefore, they use the default keys. Now, in 2024, I still see these keys used on new systems. And the funny thing is that if you take that key and decode it as ASCII, it is the name of the vendor.
What's the vendor's name?
Will this be on YouTube? Actually, I had the name of the vendor here, but when I realized that this was going on YouTube, I removed it. Yeah. But here, I have a vendor. The only reason I have the vendor here is that this is a screenshot taken from the Proxmark default dictionary. Salto is a company who makes access control system, of course, and they use both on offices, on hotels, and all over. And they have two different systems for hotels and like regular office buildings, but they use the same keys on everything. So if you stay at a hotel having a system from Salto, you can take the keys from that system and you can use the same keys at the office building. And it's only this is the A key and that's the B key, found in the default dictionary. So it's really easy to dump. And in Norway at least, I've seen this. It might be one of the most used access control systems. And interesting thing that when the customer buys an access control system, it gets the documentation. The encryption keys is not mentioned in the documentation, and that is for sure not mentioned that it is a default keys that is used. So it should be easy to change these keys. As I said earlier, the vendor said, like, how should we store the different keys for all customers? It's not possible for them, apparently. But there exist some databases for secure storage, password managers. You could have used something that's as simple as Bitwarden for saving the keys for different companies. Yeah, you should never use default keys. You should never use the same keys on other customers. 2 weeks ago, approximately, on the 25th of July, Per sent me this article in Ars Technica about the default keys. And there was an article about secure boot using default keys on many models from the large vendors of laptops and computers, like Lenovo, HP, Dell, and so on. And in this article, there was the guy who was interviewed tried to make a metaphor and compare the secure boot to a door lock system to make it more understandable, I guess. But that quote actually fits quite well with what I'm describing in this presentation. Imagine all the people in an apartment building have the same front door lock and key. If anyone loses the key, it could be a problem for the entire building. But what if things are even worse and other buildings have the same lock and the keys? That's what we have when we have these default keys and the same keys used all over for the access control systems. So, story time. As I said, I'm doing penetration testing. I'm doing a lot of physical penetration testing. So here's a story about one physical pen test I did a while back for a large power company in Scandinavia. It was a physical penetration test, and the goal was getting physical access to the headquarters to prove that we could access the network, show access to sensitive areas, and place a dummy bomb on a central location. So everything from proving that we had network access to showing that we could blow up the building. So we'll skip all the recon and the social engineering part, but basically we were able to tailgate into a temporary office building next to the headquarters. It was some barracks that was temporarily installed. There we found 2 access cards just laying around on a desk, very shiny and new, and it turned out that they didn't work because the employees hadn't started yet. When we tested the cards in front of some readers, it only blinked red, so they didn't have access. But we found out that these cards were using MyFair Classic, EV1, and several of the sectors, and had the encryption keys FFFFFFF. Never mind how many FFFs, which is the default keys, as mentioned before. Using the nested attack, we were able to crack all the other keys. It turned out there were 1 sector on the card that had data. The data looked like this. Turned out this is ASCII. We decoded it as ASCII, and we got this string for 1 card and this string for another card. Well, we didn't get the X's and the Y's though. The X's turned out to be the site ID, and the Y's turned out to be the user ID. And at the end, you had a checksum. In the beginning, you have some sort of ID. You not say so much more about that ID. That might be possible to know the vendor from that string, so don't Google it. And you have this semicolon, which is interesting because on old magnetic cards, or magnetic stripe cards, semicolon was used to divide the fields. It was a separator. So it looks like this MyFair Classic card is actually emulating a magnetic card, which was interesting. And this was a rather old system, but it's still used on a lot of places. I've seen those readers many places. They had both old readers and new readers for backward compatibility. Yeah, as mentioned, this was the data. This is some kind of ID. X's are site ID, Y's are user ID, and the ZZZ at the end is the checksum. So just what happens if we take those user IDs and we try to increment them and decrement them and see do we get any other valid cards? So we tried to change the ID to something else, swipe the card, didn't work. Then we started to think about what if we actually have a valid ID, but the CRC or checksum thingy at the end is not valid? So we tried to find a method to calculate the CRC. A colleague of mine was sitting with that, just hammering away with CyberChef and different methods for trying to find that CRC. But I didn't have the patience. It shouldn't be that difficult. We can't sit here all day in the car trying to find what CRC method to use. So I'm a big fan of KISS, like keep it simple, stupid. So the difference between those 2 cards that we had was only half a byte. So I changed the ID, started checksum 0, and incremented. On the second try, I got a green light on the reader. The card was valid, but I was asked for a pin. So we used some hours on this. We were able to make valid cards, but that company used PIN all day, which not many uses. But so this is valuable information if we are able to, if you're doing a test for a customer having the same system, which do not use PIN. So instead of copying the card and walking in with that, we had just tailgated in instead and got access to some very critical areas in that building. But it was a very interesting case, and we learned a lot from it. So a little bit more about MyFair Classic and MyFair. Whoa, time. In EU, there's a lot of BsidesLV wing cards. That's MyFair Ultralight. If you have the old firmware on the readers, there is no password. You can just dump the card using, for example, a Flipper 0, which everyone knows what is, I guess. If you have a new firmware on the readers, there's a password. So you have to dump the parts of the cards that you can dump without the password. Then you have to go to the reader to get the password, and then you can dump the rest. We also have some MyFair Classic, as mentioned before with the Salto. But here in the US, this summer, I had a road trip from New York to LA. I stayed at 9 hotels across the US. All had MyFair Classic. And out of those 9, 8 of them, I was able to crack and dump the cards using my Flipper or my Proxmark with default dictionaries and a nested attack. So just in case someone hasn't seen a hotel card being copied with a Flipper, everyone has seen that on YouTube now, I guess, but just in case. This is my hotel here in Vegas now. Just take 2 seconds to copy the card, emulate it on the door, and I'm in. But that's another video. But as I said, I'm doing a lot of physical testing. I'm very eager in doing other things than copying the cards, because it's much more easy to just attack physically on the doors in many cases. Like, for example, this. That's a hotel in Norway. So why bother with all the technology when you can just use a simple shim to open the door? So, but encrypted data. I mentioned earlier that some systems only uses the UID. When the UID only is used, there is no encrypted data. Both on MyFair Classic and MyFair Desfire, and of course the LF cards, the UID can be sniffed super fast, and you can use like equipment and larger antennas, so you can read it for like a meter, maybe more if you have some really specialized equipment. There's a large number of vendors and a large number of installations that have only the UID. And there's a lot of vendors that support everything else. It supports encrypted data, it supports Desfire, it supports a lot of secure technologies, but they only use the UID. And I think that's the reason for that is that it's easy to configure for them. They don't have to manage those keys. They just use the UID. And this is a screenshot for the application for a large vendor of access control system used a lot in Scandinavia. And as you can see, this is the default types of cards that you can use. None here mentioned encrypted sectors. Here we have a CSN, card serial number, HID prox, that's only the ID, 125 kilohertz card, prox, digits, EM, only UID, Desfire, CSN. Yeah. And most installations I see from this vendor has only the UID. I will not say the name, but ask me afterwards. One more story. This was a large international research organization. Again, we had a physical penetration test, and the goal was to get in and get access to most areas. We went in at the end of the day when someone was going out. We just went in and started to check all the available spaces in the building. And we found the janitor's office unlocked in a hallway that we were able to access. In that office, we found a locked cabinet. When we looked at the cabinet, it was locked, turned around, we found this. A box with a lot of old keys and old locks. Started to dig around in that, and we found the key for the cabinet. Within the cabinet, there was a shitload of keys and cards, including ID cards for security personnel. But the most interesting card that we found was the card for the son of the janitor, because apparently he had some summer job or something there. So we copied that card together with some other ones. Started to go around the building, but yeah, they needed a pin at night, so we were not able to get into any areas. But we came back the day after. We were two. I only had one card with me, one blank card. So I copied the data onto that card, gave it to my colleague. He went in. But after he had been in for a while, I was getting restless in my car, sitting outside. I wanted to go in too. It was boring just to sit there. This was in the middle of the winter in Norway, and it was cold. So I just took my flipper, emulating the card, walking by the security guard, like almost like this on the picture here, with my flipper in hand. I'm sure the guard had seen it, but it didn't react. And I was in. But why is so much crap still used? Can anyone answer to that? Yep. Yep, it's cheap. There exist billions of badges already, and the vendors are lazy. Why should they learn anything new when they can just earn the same amount of money or even more doing what they have done for a lot of years? And in many cases, I think that the security requirements are not specified good enough in the request for proposal. There's much focus on the price, and the customers often they trust the sellers. They're stupid as they are. They trust the salesperson who say that this is a secure system. I once asked an installation company why they still use these cards. Why do you still use these old protocols? Why do you still use only the UID? And his answer was, we just install it and make it work. We don't know anything about the protocols. That was kind of scary. So, can you upgrade access control system? If it's old enough, you have to replace all the readers, the controllers, the server, everything. It will be really expensive. Maybe like 100K, several 100Ks, depending on the size of the company, of course. If it's relatively new, the hardware in many cases support new technologies. But as I mentioned before, the people installing it, they use the old technologies because that's what they know. If it's relatively new, it is possible to only replace the badges and recode the badges and do some configuration changes on the system. The badges are often quite expensive. They shouldn't be because they're really cheap to produce, but the providers takes a lot for them anyway. I found a video on YouTube from HID, the large American manufacturer of access control systems, showing how they could reprogram, how they could upgrade the firmware on a reader. So they had, I think in this process, they had 5 different cards containing the firmware for the reader, and they had to set the reader in a special upgrade mode, and it took like 5 minutes to upgrade one reader. It placed one card on the reader, rebooted the reader when it started to blink the correct sequence of color, replaced it, put in a new card. It's like you're installing a game with floppy disks in '95. So the 5 minutes plus for one reader. It is possible to upgrade some of the readers using a mobile app, but it also take many minutes. So if you have a large installation with like several hundred readers, it will take a lot of time to upgrade the software. But it's a fun little clip. If anyone, just Google HID reader upgrade or something. So the cards are in many cases very easy to clone, so use pin all day on all places. That's the point from all the slides I had before. Roles. In most cases, not all cards have the same access, of course. How can that be misused? For example, in many cases you have a master card, a card that have access to everything. For example, the janitor has cards like that. In many places, some places, I've seen that you have seen key boxes like this, I guess. How easy is it to open a box like this? Have anyone tried? I was able to teach my daughter in 5 minutes. She was 11 years old. She used 5 minutes to learn how to open boxes like this. And inside these boxes, you can find access cards with the master role without PIN, because in emergency you don't want to use the PIN because it takes more time. So that's kind of scary. And guest cards, they can be upgraded in many cases. For example, if you remember back when I was talking about this going from invalid to a valid card, we just changed the ID. So if you have a guest card, you can try to increment or decrement from the ID on the card and maybe get more access than you should. So cards in the same number series have more access. And what about PIN codes? What do you think is the most used PIN code in this place? 1? Yeah? What digit is that? That? What about that? 8. Yeah, 2580. We were doing another penetration test, physical test, and I saw this outside, took a photo of it, thought it was kind of funny. And later we were able to get inside, getting some cards from some drawers in there. And we tried those cards on some internal doors, and we were asked for a PIN. And like, what can the PIN be? And I remembered this and tried 2580. Yeah. Turned out that was the PIN code on all the cards for every employee on that facility. More about PIN codes. One large vendor, I asked them, how do you store your PIN codes in a database? They were encrypted, but they wouldn't say how. They were not allowed to say how. This is a dump from the database. This is the encrypted or encoded, or they're obscured in some way. So if anyone wants to try to help it, find out how these are obscured, please shout out. There's another system. When you do an export of the entire database, the PIN code is in clear text. PIN in clear text. Another large vendor. Another one. Here I mentioned the name. This was during a penetration test. We were able to compromise the database server on this access control system, because I found the server, it had Lenel in its name, and I found actually a couple of weeks before, I read the technical manual for that exact system, just out of random, and I remember, there's a default password here. And I found that manual again, and then just, they can't be using the same default password everywhere, but just wanted to try with the password security, with a 1 instead of a I and a hash at the end. And I was able to get system on that box because, of course, the database was running a system. Starting to browse around the system, dumping the database, I found out that the PIN code was actually encrypted in the database, but on another part of the disk, we found an export, a CSV file, with all the card numbers, the names, the role, the PIN codes in clear text and everything. So we could just, and they only used the UID, of course, which was in that CSV file. So we can just create our own cards, and we knew the PIN code for everyone. So here's a try, you won't see so much here. I tried to anonymize, I'll scrabble most of it, but it's a PIN code at the end. And the dump was, how much did I say? 4,000 or 5,000 users. Replay attacks. Has anyone heard anything about replay attacks on access control systems? So I started off, if you remember the sketch I had, the cards at the right, the next step was the controller, and between the controller and between the reader and the controller, there is some protocols called vegan and OSTP and so on. Many of those it's possible to replay. Vegan, you have some, you even use RS-232 or some other serial protocols, OSTP. The reader communicates with the controller, and the controller opens the door if it's a valid card, as I mentioned earlier. But what if you're able to connect something here, and when the card is swiped, you're able to record that data, and afterwards you can replay it, because these are not encrypted. So, but how do you get access to that cable? Here's some card readers that I've seen on some tests. This is one from Solid Card or BsidesLV. And on the bottom, you have this tubular key. Is anyone into lock picking? Is it hard to open locks like this? It's possible to open them with just a piece of paper or a Bic pen. And this one is even easier. You can just screw it up with a Phillips screwdriver. When inside, in many cases there is a tamper switch, but we have removed several of these. I've opened many of these, but never gotten any alarm of some reason. And in some cases, you don't even need to open the reader. You don't need to trigger the tamper switch because the cables are available on other places. ESP key, anyone heard about that? That's a device based on the ESP32, which you can connect and do the replay attack. Red Team Tools by Devent Olaf and Babak, and guys that you might have known from DEF CON. They sell this at their store. It is also open source, so it is possible to build it yourself. It's quite complicated, but you can. Just a short demo, see if this works. I made a kit to try to show how it's done. So then I swiped on the invalid card, it was red, valid card. And then you can connect to that ESP key with your phone, and you can replay, and as you can see, it lights up green. So if anyone wants to build a kit like the ones shown in the movie, the video, I put it up on GitHub, the schematics for it. But I think that the ESP key is really good, but it's expensive. It costs $79, and it's very complicated to make yourself, even if you have access to the schematics. And also it uses, to connect to it with your phone, it has an AP, access point. So you can connect to it via Wi-Fi, but if you use, for example, an iPhone, connect to it via Wi-Fi, the phone often gets screwed up because it doesn't have internet access, and it got confused because it's connected to a Wi-Fi but doesn't have internet access. So I didn't like that, so I made my own project just to simplify everything. This is the entire schematics. It has codename BLESP key at the moment because it's, instead of Wi-Fi, it connects via Bluetooth low energy. And it has really few parts, just one ESP32, DC-DC converter, a couple of resistors, a couple of transistors, and a prototype board, and you can build it. If anyone wants to help me finish the code, please shout out. The hardware design is finished, but the code needs some tuning. I'm no coder. At the moment, it looks like this. If you want to do some research on RFID and access control systems, there's some tools that you need. Proxmark Mark III, I guess many of you have heard about that. This is a Proxmark III with a Blue Shark Bluetooth module on top with a battery. Everyone that do RFID need a Proxmark. If you have an Android phone, you can install the application Wi-Fi Classic Toolkit, which is also very, very handy to have. And some China stuff. This is a really cheap China card cloner. I think it costs like $10, $15. It also have options to crack encrypted cards. But then you need to connect to it, connect the PC to it, and you need to install some shady Chinese software, so I never tried it. But it's really easy to use to copy the ID on all sorts of cards. Chameleon Ultra is really good. Yeah. So if you need some tips on what equipment you need, just shout out. And of course, everyone knows this. How many does have a flipper here? That's good to see. And for the rest of you, buy one. It's fun. A couple of links to where you can buy some stuff. Lab 401 is really good, especially if you live in Europe. Red Team Tools, yeah, MToolSec. But did you think it was bad until now? Let's make it a bit more, worse. Let's see. Your access control system. You will never expose that on the internet, will you? Do you think anyone will? During the making of this presentation, I just thought it would be fun to just check out Shodan to see if I found some access control systems there. And actually, I found 3 different vendors, which I knew very well from Norway. And I found several hundred access control systems only from those 3 vendors exposed to internet. So vendor number 1, Zalto. I found, you can see in the banner information, is it blurry? It's Salto, and here's a RDP session in, yeah, for a Salto server. And also there's some web interface logons to the Salto access control system. Another one, Lenel, which I talked about earlier. Actually, I found several in the US. Access to the management interface, which might have default password, I don't know. And some of them are running the database too, which I mentioned earlier with a default password. So maybe some of the ones you can find on Shodan has a default password. I don't know. One more vendor, BsidesLV. Many in Norway and Sweden, having exposed the admin interface. And for BsidesLV, when you first log on to installation, the default username is master, and you have to change the password on the first logon. But way too many change the password to master because it's easy, master. And since these are exposed on the internet, what could possibly go wrong? I actually found a way of brute forcing the. I made a tool for password spraying against these BsidesLV boxes, but yeah, I will not say so much more about that. So that's it. Any questions?
Questions for John?
So I think you had mentioned about 9 or 10 different technologies, right, in the beginning of the talk.
Yeah.
How do you approach figuring out which technology you're up against when you go into a pen test?
If you can see the reader on Google Maps or something, Google Street View, you can maybe identify the vendor of the system, and from that you can see what kind of cards is supported by that type. And if you're able to get access to one card, you can identify the technology by using a Proxmark, for example, or a phone. And also to see if it's, let's see if I have a picture. You can easily find out if it's communicating over, if it's a HIF or LF card, using, for example, this field detector. This will have 2 LEDs. One will blink if it's 13.56 megahertz, and one will blink if it's 125 kilohertz. It has 2 antennas tuned to the 2 different frequencies, so you can easily identify that. Those are really handy to have. There are some open source project too on this. And I also was a guy here at BSide who had this, his business card had this field detector built in. Any more questions?
Well, we have to cut it off there. This was the last talk at the PasswordsCon track, and now there will be closing ceremonies in the middle ground, big room. And then, of course, there's the famous pool party starting at 10 in the evening, and then some. So thank you all for coming along. John, you're also speaking at DEF CON Village something? No, but you will be there.
Yeah, and I will be volunteer at the Red Team Village.
Red Team Village. So you can also find him there and talk to him there as well. So again, another round of applause for John. And thank you for coming to the PasswordsCon track and to B-Sides. And then there's some additional information as well. Thank you.
All right. So what we're gonna do here is we're gonna clean out the entire room. 1 second.
Something